Hello and welcome to all of you from across the world. Welcome to NodeConf Remote. I'm so pleased you could join us for the most accessible, most inclusive NodeConf yet. Normally, we can only cater for about 300 people in Kilkenny and Ireland, but this year we are broadcasting worldwide to literally thousands of people, which is incredibly exciting. All you need to join this conference is an internet connection and a computer. My name's Katie Roberts. I'm one of the technical directors here at NearForm, and I'll be your host for the next 2 days for this live conference. Yep, this is a live event, and that means you're going to be able to interact with the conference speakers. So how do you interact? Well, we've got Slido set up. So on the conference page, you should be able to see, if I'm pointing in the right direction, we've got 3 tabs up at the top: QA, chat, and polls. And through these, you'll be able to ask questions. So through the Q&A tab, you can ask questions, and we'd like you to ask speakers questions about their talks. And the game goes like this. You put great questions in Slido, and I have to ask the questions on your behalf. So there's no more scary raising your hand in that awkward moment when you're waiting for the microphone to come to you. No, there's none of that. Instead, you get me mispronouncing complicated words on your behalf. You can ask anonymously if you want to, or not. It's up to you. And if somebody else has asked a question in the channel and you think that that's really great, I would love to know the answer to that. You can upvote that question. So the more votes a question has, the more likely it is that it's going to be asked. And seriously, ask the questions you want the answers to. I can always Google the pronunciation of things. We're going to ask you if you'd like to take part in some polls. So if you go into the polls tab, you'll be able to see polls that we're putting up there, and we might be asking you things like, I think at the minute Cleaner's just put something about where in the world are you joining us from, or ask you, do you agree with what the speaker's saying? Keep an eye out for the polls in the polls channel. There's also a chat channel. Now, I've been coming to NodeConf for a few years now. In fact, some of you might recognize me. And I know it's as much about the community as it is about the technology. I would encourage you to go into the chat channels and get to know your fellow attendees. We do have a code of conduct. Please remember to be kind. Everybody here wants you to increase your knowledge and understanding. So the code of conduct can be seen on the events page. If you go down to the bottom of this, scroll down on this page below this video. We hope we've created a safe environment for everybody. But if you do see a brief of the code of conduct, or you personally feel threatened or uncomfortable about something that's happened in the context of the conference, please do speak to Cleaner and Sean, and they can be reached at events@nearform.com, or take a look at the code of conduct page and there's details on there. We really hope that you can stay with us all day for the conference. We do understand that's not always possible, so we will be putting up talks on the NodeConf Remote site afterwards. This is an international conference, and we are lucky enough to have speakers from around the world today. Over the next few hours, you'll be hearing from people from Israel and France and North America and Germany and South America, to name but a few. And very shortly, we'll be going over to Ireland to Cian O'Madian, who is the CEO of NearForm, who kickstarted it all, and Matteo Collina, who will be officially introducing the conference together. So get comfortable, sit back, and get ready for the ride that is NodeConf Remote 2020. Thank you.
Hello. Oh. Yes, I can.
Hello. Hi, everyone.
Hey! Hi, folks.
Hey. We're
Hi,
live.
Kian.
Hey,
Yes.
Matteo. How's it going?
NodeConf 2020. Come on.
Yay. We made it, man. We made it.
Yes.
Oh, thank God. It's been a bit
Yeah.
of a crazy year.
It has
But,
definitely been, Kian. You are in
yeah.
Ireland, right? You are the only one in Ireland at this point, probably. I'm
I'm
joking.
I'm in southeast of Ireland. Small town in the southeast of Ireland, broadcasting live. And where are you, Matteo?
I'm in Italy. Hey, I am in the Emilia Romagna in Italy. We are almost in lockdown here. So whatever. But it's good that we are streaming NodeConf for you today. So I'm pretty happy about being able to actually have a NodeConf use this year, which is a complete, well, actually NodeConf Remote, which was essentially our effort to get to keep the maybe we need to. How can we steal a remote flag? I don't know. I'm sorry. Sorry about this. It's a typical recurring joke of all NodeConfs that the flag gets stolen. I don't know. There have been some very good memories about past NodeConfs. So I don't know, Ken. You probably have a lot of those.
I have a couple of stolen flags here that got returned to me, actually. Some very, very fond memories. Yeah. God, we've had some times, in fairness. It's been quite the experience. Yeah, where do we start? The NodeConf came around. It was 2012. Anton Wally and I. Anton is probably there. Hello, Anton. We started the Dublin Node.js meetup early 2012, and I think we were like 3 or 4 meetups in, and we were standing down the quays in Dublin on a Friday morning, and I was talking about going to NodeConf US, and somehow in the conversation it came around where I was like, we should do a NodeConf, and Anton looked at me going, "You're crazy," and I was going, "Damn right I am. Let's do it!" And so, that conversation on the quays in Dublin back in 2012 led to the first NodeConf happening. And amazing sometimes when you have an idea and decide to go with it and see what happens, that good things can happen. So actually, funnily enough, the first NodeConf we hosted it in the Guinness factory in Dublin, which is pretty cool. And actually, we nearly had Emily Rose, who's hopefully there somewhere. There was a bit of a pyrotechnic demo that went wrong on the last day of NodeConf, and we managed to fill the conference room full of smoke from a smoke machine, and we came pretty close to having to have the Guinness factory evacuated. That was kind of pretty cool, but year on year, it's really taken a life of its own. And what really is a lovely thing with NodeConf is just the people that keep coming back every year, the new people that come to the event, and just made a lot of friends, over the years, and friends for life, not just tech friends, but real friends. And so it's very special, it's personally special to me, and of personal importance to me, to keep flying the NodeConf flag, albeit that it's virtual this year. We'll have to figure out a way to get someone to steal it, I guess. But I suppose 2020 is just it's a funny year, and the world has been turned upside down, and it's been tough on everybody, but but luckily we're still in one piece, and I guess coming into the planning phase of this year, when everything, March, April 2020 was a funny time. We were worried whether the world was going to end, what was really going to happen, and we were sitting down, and going, are we going to do a NodeConf or not this year? And it really felt like something we should do. We're going to keep that flag flying and keep it going, and unfortunately we can't meet in person, but to anyone that's attending the conference this year, there are loads of people attending as well. That could be friends of yours. They could be co-founders of a company, or they could be people that you work with on an open source project, and that's the thing that I personally enjoy about being involved in community is being a part of enabling community events to happen. If things work out well, you can sit back and just enjoy seeing people making new friends, which is so I mean, this year obviously we're doing NodeConf Remote, and next year, if we can do an in-person event, we will. If we can't, we'll do whatever we can to keep it going, because it's my intention and dream to keep NodeConf going. And I guess just in terms of this year's conference, I'd love to just give a big shout out to our sponsors. Thank you so much to Bloomberg and IBM, Red Hat, and NearForm, for sponsoring this event and making it happen. A big shout out to Collina, who's set up the conference, and Matteo and the team for putting it together and making it happen. And I think as well, I suppose another thing which is kind of a bit of a tangent or whatever, but just talking about Node in general. I mean, I can remember in the early days when we started NearForm, we were very excited about the technology. We didn't know if anybody was going to use it in a serious way. This is kind of back like 8 years ago. I can remember dreaming that you'd end up with big financial companies or telcos or whatever using the technology, and that would be a big thing or whatever. And so this year, over the last few years, really, we've had a dream come true at NearForm, where we've been really involved in helping to make the open source project happen and support it in any way we can. But then actually seeing it being used all over the world now is something that we get a great feeling from. And we had a bit of an adventure ourselves this year. So March of this year, I got a call from somebody working for the Irish government asking could we build an app for COVID-19, and so we decided we'd have a go and we'd see what we could build for them, and so we built the app for Ireland, and the app went viral, and then we open sourced the app, and it's now been adopted like all over the world. So it's now called COVID Green. That's the open source project. It's under Linux Foundation Public Health. It's green for Ireland, but it's also green for the map of the world, going back to the nice green uninfected color. It's crazy, like the work that we put in March and April, May of this year, working with Ireland, to build this system, which has been really successful. It's all down to open source, and it's all down to Node.js in a large part. The ability to be able to share that technology with other governments then and see it rolled out in other places, it's just really, really rewarding. And so at this point, there are multiple governments all over the world who are now picking up COVID Green and starting to adopt it and roll it out. And that's all down to this project that we got involved with 8-9 years ago, when we had an idea to do a conference when nobody was using the technology, and kind of got behind it, and it's now turned into something that's real in the world. And so for anyone at the conference, or just in general, like you could meet people that you end up working with for the rest of your life, or having real experiences and adventures with at this conference. And it's certainly it's been my experience, getting involved in the community. I've ended up working with loads of people that have really changed my life at NearForm, and it's all from the open source community and getting involved in that, So that's it, really. I just hope everybody has a really positive experience this year, and I don't know what else to say, Matteo. Maybe you want to add something if you're still there. Have we lost you, Matteo Collina? Okay. Oh, there you are. Hey, Matteo.
Audio problems for some reason. I don't know. Chrome went all over the place.
It's those
So
asynchronous
I am back
non-blocking
without headphones.
leprechauns.
Apparently, things are not working anymore there. We'll see what's going on. It was a fantastic run through. I listened just a tiny bit of it. So thank you for all of that. I wanted to say a few things on this year NodeConf U that became NodeConf Remote. And where we have and what we have thought when we were starting to assemble this agenda. You will see that. So one of the key things when we start working on a new NodeConf edition every single year, it's the fact of how can we get a cool balance of speakers, which is diverse and it provides different level of content and so on and so forth in Ireland. Now, usually traveling people from all over the place to a single spot. It's first of all, it's expensive, and not really everybody can travel. So this year we have decided to take a slightly different approach. So in fact, we can travel, right? We can travel, we can't move around, but this doesn't stop us in getting some of the most knowledgeable speakers to present, people that did not come to NodeConf U ever, or they only came like so many years ago. And I'm super happy about having some of them. I was super enthusiastic when we get Trevor Norris back to speak at NodeConf U, which is, whoa, for me was one of the greatest achievement of this. He's going to present some very nice feedbacks. And then there is a lot of others. There is Beth, there is Liz, there is a huge lot of people, and all the other ones that I forget now, and I'm so sorry about it. One of the key changes that we've done this year is that we have split the days when bringing the NodeConf U format to NodeConf Remote. We have tried to bridge the gap between the two worlds. In NodeConf U, you will have 3 days in the morning of talks and 3 days in the afternoon of workshops. For NodeConf Remote, we have decided to split it over the course of the full week. So welcome to NodeConf Remote week. And you will have talks the first 2 days, Monday and Tuesday, and then there will be workshops on the next 3 days. So you can actually attend there is a full roster of fantastic speakers that can deliver good talks and good workshops. And you can learn, hopefully you will learn a lot. Know that there is a massive waiting lists for the workshops. So for the free workshops, especially, I'm talking about 200-300 people each. So if you think you cannot, if you register for one and you cannot attend, please unregister. Okay, make sure that you unregister, and so that you leave the spot for somebody else. We expect a little bit of no shows, but please make sure that if you don't show up, if you don't plan to come and show up, please unregister so we can give your spot to somebody else. And without no further ado, I think it's about time that we go back to everybody else, to the big conference. It's almost about time for the first talk. So I don't know, Kian, have you got anything to add?
No, not really. I just hope everybody enjoys. I hope you all enjoy it, and you get a positive experience out of NodeConf Remote.
I just wanted to say one last thing, and just want to thank you, Kian, for creating such an amazing conference and spirit. It's fairness to say that NodeConf changed my life. So it's in a very dear place in my heart, and I hope it can impact so many other people in the future. And I hope you all love this event as much as I always have been. So, yay. Thank you for listening to our ramblings at NodeConf and NodeConf Remote, and messing the two names, whatever. And yay, it's up time that we start. So I don't know, Katie. It's about time for Katie, really, but we'll see where we are. A little bit early for some of our slot, so we might need to keep rambling here. I don't know.
Do you know any JavaScript jokes? No,
I don't have any JavaScript jokes, so we can talk about. I don't have any JavaScript jokes, but you should follow. Okay, so we can. I don't have any JavaScript joke yet, so I think it's about time we go back to our to the first speaker of the. Actually, there is a little bit of thing to say. We need to really thank our sponsors, Kian. We have forgot. I would just want to thank all the sponsors that made NodeConf Remote possible. Without them, we wouldn't have the fantastic team that is doing the streaming and all those things. So I just wanted to thank IBM, Bloomberg, Red Hat, and last but not least, NearForm, that we are the hosts. Hey. So thank you to all of them. So I would say that it's about time for a small short video from one of our fantastic sponsors, Bloomberg Engineering, and then here you go.
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull.
Bloomberg is
a high-tech,
market-moving, data-driven,
cross-platform
information company.
When we're busy moving the global financial markets,
bringing transparency to business,
and helping major players change the world,
we go through a lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
Well, it's about collaboration.
Across teams?
New ideas can come from anywhere.
Bloomberg is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work,
which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems.
Like climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局
in 73 ländern.
世界192カ所にオフィスを持つブルームバーグ
Și în fiecare birou avem toată lumea.
Diversity is essential for business success.
When we're moving this fast,
it's great to know your employer has your back.
The benefits are excellent.
We take that basic nugget of information
from the financial markets
and push it out across all our channels.
Nanoseconds matter.
Faster, but also smarter than anyone else.
And we have people answer questions they didn't even know they had.
It's all about smart speed.
We're passionate about connecting the world.
With news, analytics,
data,
seeing every angle.
With the fastest,
real-time,
borderless,
most caffeinated
organization in the world.
Information is everything. I see my ideas come to life.
My work really matters.
Did I mention never dull?
They're here. ES modules and Node.js. What can I do? That's the name of the talk. Hi, I'm Tayar. I am so happy to be in NodeConf Remote. I think 2 years ago I was in NodeConf EU in beautiful, beautiful Ireland. Hopefully, like 2021 or maybe 2022, I will be back there because that conference, online and offline, is amazing. So thank you for having me to this talk. I think ES modules, I mean, they started like 2020 basically in Node.js, and I think they're a game changer. And this talk is basically a love song to ES modules. I am part of the working group. I'm not really a part of the working group. I'm an observer of the Node modules working group in ES modules working group in the Node.js. But I've been an admin observer. Lots of, basically everything. So hopefully I'll be able to impart some of that information and some of that love back to you. So yes, they're here, ES modules in Node.js. First of all, let's give some a bit of context. What am I talking about? I'm talking about the new syntax, not module.exports and require, which is like old Node.js module system. We're talking about the new JS module system, which is part of JavaScript. Export, function, whatever, import from whatever. The ability to use what has been a standard from 2015. June 2015, ES modules are born and standardized as part of ES6 or ES 2015. 2017, that's 2 years later, ESM lands in Node.js, but that's what I call the old ESM. Lots of controversy, lots of problems. Nobody adopted it. It was still experimental, and it had lots of criticism about it. January 2020, yes, this year, some good things did happen in 2020. ES modules are unflagged and with basically good, people are talking about them mostly in a good way in 13.8.0. And this is obviously the version I will be talking about. And the answer is, why did it take 5 years? Why did it take so long to add ES modules to Node.js? Are they any good compared to Node.js? And if they are, how do I migrate to ES modules from CommonJS, which is the old module system with module.exports and require? So hi, I'm Gil Tayar. I'm like, go all the way back to the 80s, 35 years of experience, always been a developer, probably always will be, love testing code. I'm currently an evangelist and architect at Applitools. Nothing to do with this talk. We deliver visual testing tools. So if you're front end and you're serious about visually testing your app, please check it out. Okay, so let's go. We have a lot to cover. Actually, I'm not going to cover everything because in these past 6 months, they just continued adding things to ES modules, really, really great things, but we'll cover the most important things. So what are ES modules? Let's do a primer for people who aren't really exposed to that and use CJS. In CJS, you do module.exports.add equals function to create an import. That's util.js. In ESM, because it's standard, there's syntax for that. You just do an export function and whatever. To import in CJS and CommonJS, you require that file and get back the module with whatever the named exports. In ESM, you do import, get the named imports from util.mjs, again, specific syntax. Now, there's more to the syntax than that, and I have a previous talk about the differences between CJS and ESM. We're going to stop here. If you want to read about ESM, there's tons of information on the web. Notice the extension is different, JS, MJS. We will be talking about that. So see how similar they are? I mean, basically the same, except for like different syntax. So is it just syntactic difference? And the answer is no, it is not just syntactic difference. There's very big difference about that. And there are 4 main differences that I can think of. ESM is strict. And we're going to go over each of them, each event and every one of them, don't worry. ESM is strict mode, CJS is not. ESM is browser compatible, CJS is not. ESM is statically parsed, ES modules are statically parsed, CommonJS is not. And ES modules are async, CommonJS modules are not. Let's start. And by the way, these differences are part and a big part of why it took so long to build that bridge from CJS to ESM, to start thinking about how to make Node.js more of an ESM runtime than a CJS runtime, although it's going to be CJS for like 10, 20 years probably. So let's start with the differences. ESM is strict, CJS is not. Let's take this code, the same, let's look at the first thing. We have on the right side CJS. If I do an assignment to X and X isn't defined, X will become global in CJS unless I use strict. If I use strict, that part on the right side will throw an exception. ESM, because it's strict, you don't need to write use strict. Once you write that, an exception will be thrown because X does not exist unless declared. Another thing is, in CJS, if you're not using use strict, then this points to the global object, or roughly similar. So this is defined. In ESM, this will be undefined because ESM is strict. So another thing is, CJS is not allowed to import. Import assert from assert will work in ESM, won't work in CJS, because ESM is what is called in JavaScript module syntax, and CJS is what is called script syntax. So remember, CJS is not allowed to import, ESM is. By the way, CJS is allowed to do await import, but we'll talk about that later. So notice that if you want to lint code, you have to understand what is CJS and what is ESM. The editors, the linters, the runtimes, the whatever, they need a signal to know how to parse the text and show what that text means, because it means different things in different in ESM and CJS. So the creators, the people who brought ESM into Node.js decided to come up with a simple rule. The signal is the extension. It was very controversial. A module is ESM if and only if the extension is MJS, like module.js. And a module is CJS if and only if the extension is JS. Very simple rule. A lot of people call it the Michael Jackson script. So they came up with this simple rule and thought, oh, we're good. And it really is a simple rule. You see MJS, you know that it's ESM. You see JS, you know that it's CJS. Very simple, perfect. But the community hated MJS. People had, people are bound. JS is JavaScript, so why are you mucking around with that? Please don't do that. The community hated MJS. Not only that, toolings like TypeScript and editors and linters and whatnot had problems with MJS. Things started to go wrong, and retrofitting all those tools probably would work, but these things take time. And believe me, I know I took some code and moved it to ESM, and I had a lot of problems with MJS. But 2020, we have the final version of ESM in Node.js. What they did was added the ability in the package JSON to add type colon module. Once you do that, all the files under that package JSON, the JS will mean ESM, will not mean CJS, will mean ESM, so you can continue using the JS syntax. A simple thing was made complex, not a huge fan of that, mostly for sentimental reasons, also for tooling reasons, but we're human, that's okay. We are allowed to do sentimental things. Another thing, ESM this is a game changer. ESM is browser compatible, and we'll see that CJS is not, and we'll see that non-real ESM, what I call Babel and TypeScript ESM, is also not browser compatible. And I'll talk about what that means. Let's take a small Node.js ESM, a small toy project. In it, we have an MJS ESM module, which imports from another module, from this module here. Okay, imports a function greet and just calls it. To run it in Node.js, you just do node ESM module.mjs, boom, everything works. The exact same code, if you do script in the browser, in an HTML file, script type equals module, you need to type equals module, and you add a source to that MJS, the exact same browser, the exact same code will work in the browser without any transpilation needed. How come? Because when a browser sees this import, it will HTTP the file server and ask for amodule.mjs. And if your file is named amodule.mjs, it will get it. But this works only because we specified the extension. If we do like in CJS where we import from a module without specifying .js or .mjs, then it won't work because the browser will ask for a module. It won't ask for a module.js. It doesn't understand adding an extension. It doesn't work for browsers. So again, the people that brought ESM to Node.js said, we will force the extension, even if it's like weird for common JS people. We will force them to put in the extension so that we can become browser compatible. And for the same reason, when you do a require and you give it a folder name, Node.js, when you do a require in CJS, it will look for index.js, and it has all these rules to look for other things. Nothing like that in MJS world, nothing like that in ESM world. You have to specify the path to the file with the folder, with the extension, with the index.mjs, whatever needs to be done, it has to be there, all for the sake of browser compatibility. And I think this is a brilliant decision, and it's a good decision. Wait, but what about bare imports? If you do import from an ESM module like Lodash or whatever, this doesn't work in the browser, because in Node, we do the whole Node modules thingy, right? So this, first of all, this still works in ESM. You don't have to specify the path. You don't have to specify /node module / an ESM module / whatever. You can just specify the bare specifier, and ESM will still crawl up and look for it in Node modules and all that. So they work just like CJS, but that means that this code does not work in browsers, which is true today, but they will. There's an extension that is being like standardized or trying to be standardized. It actually works in Chrome today, which is called import maps. And the way this works is this. In the browser, again, you specify the script, and you specify import, and you specify a bare import. A bare specification. And what it does, it will look in the script import map and look for that name and know what the exact extension of that file is, the exact path to that file is, and it will just work. So bare specifiers plus import maps will give us browser compatibility even for bare specifiers, basically for all the code you write in Node.js. So we're getting full compatibility between Node.js and browsers. Obviously, if you're doing things like using FS or OS and everything, that won't work because browsers don't support those modules, but JavaScript code will work. So full compatibility between Node.js and browsers inside of packages, as I said, because we need to specify the whole path, relative, all imports are compatible. Between packages, a build tool will generate an import map. The import map will be included by the HTML, and boom, instant compatibility with no Webpack, by the way. Notice that we are not using Webpack. Obviously, if you have hundreds of packages, this won't work because in terms of speed, that won't work. But people are working to make that also not a problem. I think in 1 or 2 years, Webpack and its brethren will slowly, I hope, slowly fade away, and we will be, at least in development mode, and we will be able to use ESM and modules without any need for a build tool. So yay, full browser Node.js compatibility. ESM is statically parsed. And let's look at how CJS modules are loaded. This is like a graph. This loads this, and these load the two others. In CJS, you don't load a module, you execute it. And once you reach require, then the require itself will load the second package, second module, and run it, which gets to the require, which loads this, writes the console log. And when it does the require, it runs this. That file will do module.exports.greeting and go back. But notice what happens. Here, we're exporting greetings. Here, we're getting greet. So what will happen is greet will be undefined. So it will say during execution, greet is not a function. In ESM, it's different. Same thing. I just transpiled to ESM, same code. First of all, we're not executing the code. We're parsing it, looking at the imports. It looks at the imports. Node.js will look at the imports. Browsers too, by the way. See that hello.mjs. Load it, not executed yet. We're still in the loading. Parse it. Find the export imports and see that they're okay. And then goes on to the next import, which will bind who and who together. Then it goes to the next import and try to bind greet and greetings and say, whoa, there's a problem here. Notice we haven't executed anything yet. So what it will say is syntax error. The requested module does not provide an export name greet. So the parsing binding fails before execution. Let's fix that and change it to greetings, and we're good. Now Now comes the execution part. So how does the execution part look like? Now it's starting to run the code bottom up. It will execute module number 1, and then module number 2, and then 3, and then 4, and we're done. Totally different from CJS, and remember that it looks very similar, but in terms of execution model, it's different. So static parsing, yay, great, great, great. Well, actually not that big of a deal, because in the day-to-day, does this really matter? Not allowed. But it allows the fourth thing, which is very important, which is ESM is an async module loader. Remember the load, parse, and bind thing? Think of that loading and parsing 3 and 4 can theoretically happen in parallel. So if you have a big tree of hundreds of modules, loading and parsing them can happen concurrently before execution starts. Now, the execution itself has to happen synchronously, like as we saw 3, 4, 2, 1, because that's how the specification defines it. But loading the files and parsing them can happen asynchronously and concurrently. So loading and parsing is async and concurrent in ESM, but in CJS it's synchronous. So if I have a require, everything stops. There is no event loop, there is no nothing. Even if the require is like not in the beginning, but dynamically loaded, that require will stop until the module and all its submodules will stop. ESM, on the other hand, if we do an await import, other async things will continue work because the ESM loader is asynchronous. So it doesn't stop async actions, while CJS, if you do a dynamic load, it will stop everything. And because of that, ESM supports top-level await, and CJS doesn't. And what is top-level await? Top-level await, I think, is stage 4 already, or maybe stage 3. It's basically a standard, which says this. Today, if you want to await something, it has to be inside an async function. But what if you want to await on the top level? Up to now, it wasn't allowed. But now we can do that. So if you want to asynchronously read a file, you can do that today. I think Node 14 allows that, maybe Node 15, not sure. So await fs read files, and you can read the config. Or if you want to do some kind of conditional import, so based on the platform, await Windows stuff or Unix stuff, then you can do that with ESM, and and you can do that. And if you have like this script which uses asynchronous things, you don't have to wrap it anymore inside anything. So this is great. Top-level await is an amazing feature. It's like it closes the loop in terms of async await. But because CJS is synchronous, you can't really retrofit it to support top-level await, which basically means asynchronous execution of modules. But ESM is asynchronous, so we're good, and ESM can use top-level await. So to summarize, CJS versus ESM. ESM is strict, CJS is not. ESM is browser compatible, and I think this is a game changer to merge the worlds of front-end and back-end. CJS is not. ESM is statically parsed, CJS is not, which is not that big of a thing, but it enables ESM async execution, supporting top-level await, and probably other features in the future. CJS is not. Woo, yay, ES modules. So, what about ESM using Babel TypeScript transpilation? I mean, a lot of people do that. Even in Node.js, which surprises me, they use the import syntax and everything, and Babel and TypeScript, well, basically what they do is they transpile import to require. A little bit of magic around it, but not a lot. Basically, every import is transpiled into a require. So, first of all, because every import is a require, you don't get async parsing and execution, you don't get, which means it's not spec compliant, and you don't get async await, okay? So even if you have import and you're transpiling and using Babel, you don't get async await. Not only that, ESM using Babel TypeScript, because it import turns into a require, it uses the Node.js CJS module resolution. So you don't have to specify the extension, you can use all those shenanigans you used in CJS. So basically, not browser compatible. And it's ironic because Babel and TypeScript, well, mostly Babel, was first of all used in the front-end world, which today is uses it extensively, and it's not browser compatible. It's ironic. So ESM is strict. Well, okay. So is Babel. Just add use strict when transpiling. ESM is browser compatible. Babel transpilation is not browser compatible. Okay. So if you try and take that code and run it without Webpack, just like in Node it's possible, it won't work. ESM is statically parsed. Babel transpilation is not, because it's only transpiling import to require. And ESM is async and supports top-level await. Babel transpilation is not and does not support top-level await. And last of all, and this is a pet peeve of mine, ESM is native. It just works, okay? No transpiling and everything. Babel and TypeScript are transpile with all the difficulties that come. Some people like it, some people don't. But wait, there's more. Exports. Remember main in package.json, where you can specify the entry point to a package? This is classic CJS. It works. So if you import something from a package, you will get main.mjs. But as we all know, you can backdoor into, deep link into the package and take whatever you want from there, even if the package member didn't want it. And sometimes that creates an inability to change things internally because people are depending on that deep linking. Until now, ESM has the ability to add, and not main, but exports. So you can specify a mapping from a file to another, from a path to a file. So dot is just like main, and dot/world is world.mjs. So if I import from a package, I will get main.mjs. And then if I import from a package/world, I will get world.mjs. By the way, we got it because of ESM, but it is also supported for CJS. So, but once you have exports, those are the only entry points. You cannot write this. Just remember to keep the main field for backward compatibility, because you still want other people to use that. What else? Conditional exports, and this is great because this is a bridge from CJS to ESM. I don't have a lot of time, but what if I want a package that I can both require and import? And the answer is you can, by specifying conditionally, this is import entry point, this is the require entry point. And that will help build dual mode libraries that will work for both ESM and CJS. Just a buyer beware if you're using this code, please read the documentation carefully. There are some caveats around dual mode libraries. Okay, and there's even more, but I have only 25 minutes. Migrating, toy application. I have main.js and greet.js. Bottom up is taking the bottom level modules and changing them to ESM. I just changed it to export. Now I can't use require because require doesn't work with ESM, so I do an await import, but I don't have top level await, so I wrap it up in an async function. Now, top down means I want to change MJS. One way of doing it is creating a require. You can create a require and then use require in ESM. That's also ability. Another thing is to just change it to an import. We now support named imports from CJS, but caveat, not all of them support that. If that doesn't work, use default export from import from CJS. So are we there yet? Can we start migrating? And the answer is yes and no. If you're on it, if you're building libraries, please start the migration process. Theoretically, you have all the tools. They're a bit rough around the edge. They work sorta. In a year, they're probably all going to work. Start working on that. Start migrating in a while and slowly. Summary, ESM is much better than CJS. ESM is strict, CJS is not. ESM is browser compatible, it's statically parsed, it's async, and it supports top-level await, but breaks compatibility with Babel and TS ESM, with old-style ESM. And this is the reason, in my humble opinion, that it took so long. But it's worth it because standards compliant is a must-have. Async module system is very important, and browser compatibility for me is a game changer. And a slow migration from CJS to ESM is possible using dual mode libraries and top-down migration. Tooling still needs to be ready. It's almost there. But yes, they are coming, and hopefully, I have a video. So can you please show it? I can't show it from my. Let's see.
I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion. I watched C-beams glitter in the dark near the 10-house gate. All those moments will be lost in time, like tears in rain. Time to die.
That's it for ESM. Please follow me at Tayar on Twitter. If you have any questions, I understand I have about 2 minutes for questions, but if not, please DM me directly on Twitter at Tayar. Questions?
Hi, Gil. Hi.
Yes.
That was fantastic, and I loved that Blade Runner at the end. That was hilarious.
Yeah.
Thank you so much for your talk. It was
Thank
really,
you.
really informative. We've got a question coming through from, I think it's Mateus. Where do some of the ideas like top level await are inspired by Dino? Oh, sorry. Do you want me to ask that again?
Dino.
I didn't do very good. Yes.
No. Yes. The idea for top level await. First of all, Miles Borens is the champion, and he did an amazing job in pushing it through all the stages of DSC. Dino wasn't inspired by top level await. Just Dino implemented it before Node.js did. I think so. They're both very standards compliant, great runtimes. The inspiration, well, basically, this is like a perfect feature. It just makes sense, and somebody had to do it, and Miles Borens did it. And thank you, Miles.
Okay, great, thank you. And now that you see ESM support getting more stable, do you see any more adoption coming for ESM?
Hello?
Hello?
Have I lost?
I think I've been lost. Hi.
Hello? Yeah.
Oh, hi, I'm back. I'm back. Oh.
That was awkward. That's okay.
I was talking to myself. So now ESM support is getting stable. Do you see more adoption coming?
ESM, yes. It'll take time. These things take time. I mean, transforming a whole ecosystem from CJS to ESM, I think 5 years. But, it's going to be exponential growth. And you can see the tooling there. Most of the testing tools are already there. Mocha, Ava, Tape, Jest is coming around. Mocking libraries. I did the implementation for test double, so we know mocking libraries can work with ESM. I'm guessing sign-on is on the way. I would say a year before it's really like production ready, and after that we'll be seeing it change. The big question is whether it will affect the front end world and whether they will also start becoming Node.js compliant and browser compliant, and the signs there are accepting it, at least as far as I can see. I think like 2 to 5 years we'll be looking back and say, how did we even work with CJS?
So should we all be starting to rewrite all our modules on NPM?
Slowly, do a pet project first, and then yeah. I mean, I'm not crazy, but in a year you'll be seeing people doing it. Like I'm going to start with at Applitools, definitely.
Brilliant. Thank you ever so much, Gil. I understand that that's all that we've got time for. So thanks ever so much for your talk, and we are going to have a word from our sponsor now. So over to our Red Hat sponsor.
So welcome to NodeConf Remote 2020. We're happy to be back again this year. I'm Michael Dawson, the Node.js lead for Red Hat and IBM, and I have with me Luke and Bethany.
Hi, I'm Luke. I work at Red Hat. I'm a senior software engineer where I work on Node, trying to make a good developer experience on OpenShift, as well as part of the NodeShift project. Beth?
Hi, I'm Beth. I'm a senior software engineer at Red Hat, where I'm mainly involved with the Node.js project. In particular, I'm involved with the Node.js release working group, and I'm also a TSC member there.
You know, I just realized, as a fun fact, that the first time I met the two of you was actually on the bus to NodeConf 3 years ago.
Yeah, I remember those bus rides from the airport down to the location very well. Usually they were really early in the morning after flying overnight, but lots of fun. So this year we have some great talks and labs. Bethany, what are you going to be talking about this year?
Yeah, so my talk this year is named Chronicles of the Node.js Ecosystem, the consumer, the author, and the maintainer. And you get bonus points if you can guess which film I named my talk after. And the talk's mainly about the challenges around the massive Node.js module ecosystem, all of the NPM modules that you build into your applications. And as well as highlighting the challenges, it's also going to be a bit about the Node.js package maintenance working group, and to talk about some of the work that they're doing to try and mitigate some of these problems and build tools to help consumers of Node modules. Luke, what's your talk about this year?
Right, yeah, I'll be giving a talk. It's going to be called Serverless with a Chance of Cloud Events, also taking it from a piece of literature. So in the talk, I'm going to go into how there's, right now, there's this kind of a lack of a way of describing events across different platforms, sort of different serverless platforms, and how Cloud Events, which is a fairly new spec from the CNCF, how it aims to kind of try to describe these events in a common way. And we'll see some examples on how we can use the JavaScript SDK to emit events and receive those events as well. Michael, I think you have a talk this year too.
Yeah, I do, although I figure after both of yours nice literary references, I'm not doing so well. But anyway, my talk is about real-world success stories. We all hear that Node is being used in some really big deployments, but I'm going to talk about some concrete examples that we've been doing both internal to IBM and with our customers. And then finally, I'm going to talk a little bit about some of the thinking we have along sharing some of the experience that we've gained building and operating those larger deployments. We also have some great labs, though. One of the labs you can come and take is a lab on Node-RED and using AI with Node-RED. Node-RED is a great way to do some graphical programming, to pull together components like AI. And you can also, of course, drop down and code directly in Node.js as well. Luke, I think you're going to tell us about another one of the labs?
Right, yes. There's another lab. It's called Kubernetes for JS Devs. This is going to be given by one of our colleagues, Joe Lord. Now, if you're interested in building and deploying cloud-native applications, this is probably a good lab to attend. Even if you're new to Kubernetes, it's going to go over a lot of things to tell you what you need to do to get started.
Thanks. I think Bethany's going to tell us a little bit about the booths that we have too.
Yeah, so both Red Hat and IBM have booths at NodeConf this year, albeit virtual this year. And at RBF, you'll have the opportunity to live chat with some of our colleagues who are open source contributors across IBM and Red Hat. And it gives you the opportunity to ask any questions you have about maybe Red Hat and IBM offerings, including things like how you deploy Node.js applications, in particular to OpenShift. And we also hope to have a cool draw where you can enter to maybe win some cool stuff.
Yeah, it's also a great place to talk to and learn more about our involvement in the Node.js project and the OpenJS Foundation, as a number of our team members are very actively invited. And I guess just to close out, I'll say that both Red Hat and IBM are very proud to be sponsors of the conference once again. Always found that it's been a really interesting and unique conference, and looking forward to the content this year. Talk to everybody later.
Hi everyone, my name is Beth Griggs and I'm a senior software engineer at Red Hat, where my role is all about Node.js, from kind of contributing to the upstream Node.js project to building tooling to support Node.js deployments to OpenShift and Kubernetes. And one of the areas the team's looking at is how we can encourage and support our enterprise clients to leverage Node.js. And one of the key areas of concern that always pops up in discussion is the usage of module dependencies in their deployments. And today I'd like to share some of those concerns from a few different perspectives, and later talk about the work the Node.js Package Maintenance Working Group is doing to alleviate and provide guidance for some of these issues. So first of all, you probably all know the value of Node modules. I think they're personally one of the most powerful things about Node.js, and probably why I choose to use Node.js over and above a different runtime. With over almost 1.5 million modules on the NPM registry, there's a high chance one exists to help you complete the work you want to do. So just as an example, in about 17 lines of code, using just one direct dependency, I can build a small program that scrapes all the tweets for NodeConf Remote. And this is just to demonstrate the Node.js module ecosystem and how it enables you to be productive very quickly, use quite high-level APIs, not solve problems that others already have, and focus on the business logic of your application rather than repetitive level technical implementation details. But the use of modules pose different challenges for the consumers, authors, and maintainers of these modules. And that's what I'd like to spend some time digging into today. So first, let's start with the consumer and some of the concerns around consuming Node.js modules. So if I look back to my other example of the small Twitter scraping app, that was using just one module. So with just one module, I can build a small application to scrape tweets. But that's actually a lot of code in production. When you look at the whole tree of dependencies, so all of the dependencies that one Twitter module pulls in as well, there's a total of 49 unique packages and almost 60,000 lines of JavaScript. And this just goes to show that the amount of code you write is significantly different from the amount that you're responsible for when you deploy to production. And it's important as a developer to think about the code you did not write just as much as the code you did. The more code you deploy into production, the more risk. You've got a larger attack surface area and more code to manage. And I find these are 5 risk areas that pop up a lot in discussion. So security, licenses, maintenance, breaking changes, and compatibility. So I'm going to dig into each of these a little bit at a time. So first, looking at security. There was a survey of Node.js developers covering the state of Node.js security from Node Source and Screen. This is back in 2017, the survey. And from those results, they found that 84% of Node.js developers were moderately to very confident in the security of Node core. This means in general, they are very happy to consume the Node.js runtime, and they had confidence that security issues in the runtime would be detected and resolved in a timely manner. But when it came to looking at the third-party packages they were using, this fell to just 16%. So there were already concerns about the security of their module dependencies. There are some small steps you can take to try and reduce this risk. They won't solve all of your problems, but there's some steps towards mitigating your risk. So the first is to use things like npm audit, GitHub security alerts to alert you of any known vulnerabilities in your applications. You can also publish a package JSON or a package log file to ensure that you don't automatically pick up new versions of modules. And the reason why you might not want to do this in your deployments is because if someone publishes a malicious or broken release, you don't want your deployments to automatically update that. So once you've published a package log file, you tend to use a tool such as Dependabot to automate the updates. And that means that any updates to your dependencies will be run through your CI pipeline before making it into production. This is just a safety check to ensure that you don't accidentally pick up a malicious release. And there's also a lot of commercial security tools you can build in to your applications to help reduce your risk of deploying insecure code to production. And then there's licenses. So I'm going to preempt this little section with the I am not a lawyer caveat, please don't sue me. But why should a consumer be concerned about licenses? Well, if you consume open source libraries and then distribute the software, your software needs to be compliant with the licenses of the linked libraries. And that's not only the license to the direct dependency, that is the licenses included in the whole dependency tree. And I find license types can be loosely grouped into 3 areas. So you have protective or copyleft type licenses. And if you use one of these, your software has to be bound by the same conditions as the linked software. Then you have kind of the middle ground, you have weakly protective licenses, and these tend to have less restriction when you're only dynamically linking to source. And then you have public domain or permissive licenses that allow you to do almost anything except sue the author. So these kind of things, public domain and permissive tends to include licenses such as the MIT license. And sometimes it can be really difficult to understand the license terminology. We're not all lawyers. So there's a couple of tools that I tend to use for reference. So there's tldrlegal.com, which is software licenses in plain English, and also the GitHub licenses view now gives you an overview of which licenses provide certain permissions, limitations, and conditions. And to try and understand which licenses you've got included in your whole dependency tree, you can use a module called License Checker. And this will output all of the licenses it can detect in your module tree. There's a big caveat with this though. It will only show the licenses it can actually detect. It's possible that there's additional clauses, duplicate license files, etc. that it doesn't detect. And for what it's worth, when I've worked in enterprise settings, this kind of check isn't enough. We have to submit all of our module dependencies to our lawyers to review the individual license files one by one and ensure they're okay. But in terms of just a high-level check to see what you've got in your application, it is worth doing. And then there's maintenance. So I'm sure most businesses understand that once you've built this piece of software, there's an ongoing maintenance cost that you need to account for. But when most of the code isn't your own and it's coming from your dependencies, you also need to consider how well maintained your dependencies are. And there's a couple of questions you can kind of ask yourself before consuming a module to help determine the maintenance state of the module itself. So the first thing to check is, are you using a deprecated module? If you are, then try and move off of it soon, because there's no chance in getting security vulnerabilities fixed or anything like that. So you're putting yourself at risk there. The other kind of questions I tend to ask myself are issues in the module being fixed in a timely manner? Are there still regular releases of the module? How active is the development, and how many maintainers are there? Do you want to build your enterprise apps on top of a module that's just maintained by a single person? That seems like a high-risk thing to do. And there are a few tools out there that can help you analyze the activity and maintenance of a module. For example, there's a GitHub Insights view that will output some metrics such as how many issues were fixed in a given time frame, how many new releases, etc. And there's also a npms.io, and that kind of uses a similar set of metrics to rank modules based on activity, etc. Again, these won't solve all your problems. It's still possible that a module may end up being not maintained in the future, but it's a good check just to gauge before you're choosing your module. And with security maintenance and licenses, there are steps you can take to reduce risk. And I think the biggest way to reduce your maintenance risk in your dependencies is to contribute back. If you contribute back, you get familiar with the code, you have some influence in getting bugs fixed, and you may even be able to influence which features get created in your dependencies. And I appreciate not every company can afford to dedicate time to contributing back to your dependencies. But if you don't have time, there's also the financial support option. So you could use things like NPM Fund or GitHub sponsors to help fund the maintenance of that module going forwards. And another concern is breaking changes. So if you've got an application in production, you don't want to suddenly have it broken when a module updates. The first thing to do to prevent this happening is check that the modules you're using follow a versioning scheme. One of the popular ones that tends to be used in Node modules is the SEMVer, semantic versioning scheme. So in this case, you only expect to deal with breaking changes when the first number is incremented. But you also need to ask how strictly are the authors and maintainers following the versioning scheme. Sometimes things are down to interpretation. For example, a particular bug fix may land as a patch, but it could actually be breaking. And sometimes they make the decision to land it as a patch instead of a breaking change. So you really need to take a look and try and gauge how strictly they're following the SEMVer. And there's also the angle of how often are they creating new major versions. You need to bear in mind before choosing this module, can I deal with a upgrade every couple of months if that's the time frame that they're cutting new major versions, or maybe it's a longer time frame. Maybe they release one major version per year. So in enterprise, there's still relatively long release cycles out there. So you just need to bear in mind the cadence of new major versions when choosing which module you're using. And then there's the compatibility angle. You need to bear in mind whether the Node.js version and the module version you're using are both compatible with each other. In some cases, the modules will provide nice support matrices to say, hey, version 19 of Happy works on Node 12. This is which version you should use for Node 14. It is definitely something that helps, but this isn't widespread yet. So that's just some of the concerns the user faces. But what about from the author's point of view? Imagine an author creates a module as a hobby or just a personal project and it gets really popular. This can pose a lot of challenges for the original author, who may not have anticipated the expectation that comes with the success of their project. And I think the same 5 areas of concern apply to them too. So if you look at security, as an author, is there an expectation that you will respond and fix security vulnerabilities? Can you actually commit to fixing them in a timely manner? Can you cope with the influx of reports? And what if the fix that I make breaks some people? These are all things that you need to ask yourself as an author. And licenses, again, are important for authors too. The first thing to check is, have you chosen the right license for your project? You want to choose the right license to protect yourself from certain scenarios and just ensure that your project is used the way you want it to be used. And there is a tool called choosealicense.com that, again, can try and help you make this decision. And maintenance. So maintenance is a concern for authors just as much as consumers. As an author, there may be expectations that you respond to any issues or open PRs in a given time frame. There may be expectations that you will patch bug fixes. There may even be expectations that you accept certain feature requests. And breaking changes, again, are also a concern for authors. As an author, when you make a breaking change, how do you know who it's going to break? For example, it's not always obvious as a module author who is relying on your module. And if you patch a bug for one user, that might be a feature for another. So you may be in a kind of catch-22 situation where you don't know which way to go. And at the moment, how can they actually test the impact of their changes? And again, compatibility is another concern for the author too. How can they keep up to date with the latest Node.js versions? And how can they manage the expectation of which release lines they support? And then there's the other scenario, handing over modules. So it's very common in the ecosystem for a module author to be overwhelmed and not be able to keep up with the influx of reports. So how and who can they ask for help? And also, how could they find someone trustworthy to hand over the module to if they no longer have time to maintain it? I don't know if you'll remember the FlatMap stream incident. This was actually a social engineering attack. So in a situation, the maintainer no longer had time to maintain the module. The attacker originally appeared in good faith and was offering to take over maintenance, so helping out, triaging issues, patching bugs, and eventually gained enough trust to have authority over the repository. And then once they had that access, they published a malicious release. So I think this just really highlights the need for some concrete defined processes for handing over popular modules in the ecosystem. So that's some of the challenges from an author's perspective. How does the maintainer fit into all of this? And it's at this point I would like to introduce the Node.js package maintenance team. All the challenges I've spoken about today are things the Node.js package maintenance working group are exploring. The working group was started in 2018 and it was established to focus on the sources of friction to module ecosystem adoption, particularly focusing on enterprise usage. At the time, it was quite well known that the highest level of comfort was with clients using packages that were stable, and where they had confidence that the modules would have ongoing maintenance, predictable releases, and that they would be able to easily upgrade to new Node.js versions. But it was also kind of known at the time that a lot of widely and broadly used modules in the Node ecosystem were not getting the basic maintenance they needed. And that's where the package maintenance team working group fits in. We have representation from all three of these personas, so the consumers, the authors, and maintainers. And that includes maintainers of Node Core and NPM. We've got a range of companies involved, all representing different use cases and viewpoints. The aim of the package maintenance team is to provide guidance for module authors and maintainers. And the way we're doing this is by documenting best practices, documenting process for authors and maintainers to follow in certain situations, promoting responsible and sustainable consumption of modules, and also manage the expectation between consumers, authors, and maintainers. And to start the package maintenance working group, we had to set the groundwork first. And we started by surveying the state of the ecosystem. We set out to find what are the most common problems consumers, authors, and maintainers are facing, and also try to identify what are the most time-consuming tasks. And we worked with Express at first, and from working with the maintainers of Express, we managed to identify a couple of key problems. The first problem they found was they struggled to keep the state of issues across all of the Express modules. I don't know if you're familiar with the Express GitHub organization, but they actually store a lot of their modules, the module dependencies of Express in the same organization. So when issues are raised, they could be raised in the Express repository or one of the dependents of Express, such as Malta. So it can be quite difficult to keep track of all of these. And in general, the Express maintainers found they're just struggling to keep up with the massive issues raised. You can imagine such a widely used framework with such as Express gets a lot of issues raised. And from working with the package maintenance team, we got together to try and figure out a solution for some of these problems, or at least try to help some of these problems. So the first thing we did was try to define a set of best practices for triaging issues. We then tried to define a pathway for volunteers to sign up to help modules. And since then, over the past year or so, we've managed to successfully set up a couple of triage teams. So for Express, we've set up this triage team where volunteers can sign up and help triage issues. And even more recently, we've set up one of these teams for Node.js Core. And in terms of our best practice documentation, we're meeting every couple of weeks to try and flesh these out. So we're trying to publish best practice documentation to cover things such as licensing, testing, versioning, support, to act as reference, particularly for module authors and maintainers, to make good decisions when creating their modules. On top of this best practice documentation, we're also looking to add some tooling and resources where appropriate. For example, if you were to look at our testing best practice documentation, you'd see it first says, hey, you should definitely test your module. Ideally, you should use some kind of CI pipeline for your testing. And it also covers what the minimum versions you should focus on in terms of Node.js versions. So in this case, we recommend that module authors test against all the LTS versions of Node, the long-term supported versions, and also the current version. The reason you would test against the current version is so that you can ensure your module keeps up to date with the latest changes in Node. And when the new LTS version comes out, hopefully you should have a smoother migration path in terms of updating your module. And as well as the documentation and best practice guide that we've got here, we're looking at creating some resources such as some consumable Travis YAML files or some template Travis YAML files for module authors to pull in so that they can easily cover these Node.js versions. And one of the other interesting things we're exploring is to publish support information in the package.json file. So this is really aiming to manage the mismatch in expectations between consumers and authors. We're exploring whether publishing things such as which versions the module aims to support, the expected response time to issues and PRs, and the backing of the module into the package.json, and whether that would help consumers make better decisions about which modules to use, and it would help authors not being suddenly overwhelmed in their hobby projects with people expecting a couple of day turnaround issues or fixes. So it's just one way we're considering how we can get this information to consumers and help the authors. On top of this, we're looking at whether we can build some tooling, and we've started prototyping tooling for this, where a consumer could run the tool and output some of this information in their module tree. But the challenge here is we first need wide adoption of the addition of this information to the package.json. And I spoke a little bit just now about the tooling that the package maintenance working group's working on. We're actually building a lot of this over in the PKG.js GitHub organization. And this GitHub organization sells itself as tooling for package maintainers by package maintainers. So we've got a lot of maintainers over in this GitHub organization. We're working on a variety of tools. Some of them support consumers, some of them support authors and maintainers. And one of the cool tools we've got over there was the dependence tool. So this tool is aimed to solve the problem of module authors not knowing the answer to the question, who is depending on me? So you can pass this tool a package name and it will find all of the modules depending on you. And you can pass it filters such as by downloads. So in this example here, we've looked up the dependence of Express, the top 5, we've sorted it by downloads, and we can find out that the most depended on module that depends on Express is the Webpack dev server. And the reason this information is useful for the author to know is so that they can, when they're making maybe a breaking change, they know which modules they need to check will still work, or at least which modules they need to reach out to say, hey, I'm making this breaking change. If I make it, it might break the ecosystem. Can we work together to try and patch this or find a good solution? And going a step further, another tool we're working on is WIBI, which stands for Will I Break You? So this really is trying to answer the author's question of who will I break when I make this change in my application. So you can kind of think of this tool as a depender bot, but for testing whether you as an author are breaking your downstream modules. And what it will do is it will actually patch the package JSON of the person depending on you, and then open a PR and run CI. And then you can get the response back to find out whether you're breaking the downstream, your downstream dependence. This is still in flight. We're not quite at the MVP just yet, but it's definitely an interesting tool, and I can certainly see it helping at least us with the management of our modules. So what are the next steps for the package maintenance working group? Well, we're going to continue to seek consensus on best practices and processes. We're also going to continue to build the tooling to support consumers, authors, and maintainers. And we're also going to continue to try and support more modules in need of help by recruiting triages. The package maintenance team should be seen as a space where if you're struggling with the maintenance of a module, you can raise an issue and we will try and figure out whether we can find anyone to help triage issues. And if you wanted to get involved, there are a few easy ways to do so. The first is to check out our guidelines. We'd love you to tell us we're wrong and why, or tell us that we've missed your use case. I think it'd be particularly interesting just to get some more feedback. You could join our meetings. So we discuss a lot of these best practices, processes, concerns in our meetings. They happen every 2 weeks. You can find the info on how to join in Node.js.org calendar. You could help us build tooling to support consumers, authors, and maintainers. So over in the package pkg.js org, you could actually help us build out some tooling, particularly the Wibby tool that we're working on at the moment. Or you could sign up to become a maintainer. So you could actually sign up to help triage issues and contribute to popular modules in the ecosystem. Again, contributing to your dependencies is one of the key ways you can manage your risk of consuming modules. So it's definitely something you should consider. All of the information, kind of our best practice documentation, can be found in the Node.js package maintenance GitHub repository. And yeah, so we've covered some of the concerns users and authors face with the Node.js module ecosystem. We've taken a quick look at some of the work that the Node.js package maintenance working group is doing to alleviate some of the concerns. And I think the biggest takeaway I'd like you to have is I do believe the best way you can reduce your risk of consuming open source modules and dependencies is by contributing back to them. And with that, I'll leave it there. Thank you all for your time, and I hope to see you at our meetings or on GitHub.
That was great. Thank you, Beth. That was really, really interesting. And that flat map example that you used there, that brought back some awful memories for me. It affected me. I imagine there's plenty of other people online now as well who will all be going, oh, yes, so many days lost. You talked about some great resources there. Is there anywhere that we can go that we can find those resources specifically around? Carry on.
Okay, so sorry. In the github.com node.js/package-maintenance repository, you can find our best practice documentation. You can also find our issues to cover our meeting agendas in there. You can cover our issues to cover our next steps and next focuses. In terms of the tooling, you should be able to find the tooling over in the pkg.js GitHub organization, and we've got lots of different tools being built in there, so just take a look at those.
Great, thanks. So we've got a question here from, I think the name's Nemo. Do you have any thoughts on the moderation of open source packages that you'd like to share?
I'm not sure what's meant by in terms of moderation. Is this in terms of
because it isn't moderation, I do apologise. This is my not reading the question properly. Do you have any thoughts on the monetization of open source packages that you'd like to share?
Yeah, it's definitely interesting. Financial support is definitely one route to try and solve the maintenance problem. In terms of, I don't know, pay for downloads, that's not the kind of thing I'd like to see personally. So like paid for modules. I do think keeping everything open source but funding maintenance is possibly the way to go. I know there's a lot of challenges there. We're not quite in a good state where open source is adequately funded these days. But the other aspect is if you are a large enterprise, investing in maintaining these modules, so dedicating some time of your employees, I think that's the only other solution we've got as well. So I think the two approaches are just to either financially support using things like NPM Fund or GitHub sponsors, and encourage your larger enterprises that are relying on this free software to contribute back to them.
Great, thank you. I've got to say that Will I Break You feature, that sounds amazing. Having worked in a project where I had to be constantly aware of what might happen because it affected so many people. Do you have any sort of idea of when that might land, or is it still in the ether?
Yeah, so we're at the point where you can run it in your upstream module, and it will push a branch to the downstream module and run the CI, and you can run WIBI results and see the results. So in terms of a very, very bare bones implementation, it's there, but we are actively working on trying to flesh it out and make it a bit nicer UI, maybe go the step further into opening pull requests. I hope by next year we can make some good progress on it.
Okay, well, I'm afraid that's all the questions we've got time for. Thank you ever so much, Beth. That has been really great. As for what happens now we are moving over to a break time for NodeConf Remote. So we've got 30 minutes, so go off, get a lovely cup of tea, go get yourself something, a snack maybe. Stick around because later today we have Matteo Collina and Anna Hussein will be talking. Anna Henningsen, sorry Anna. And I look forward to seeing you all again soon. Okay, back in 30 minutes. Have a great break. And now, it's Matteo Collina. So Matteo is a technical director at NearForm. He's author of the Fast Logger Pinot and of the Fastify web framework. He has over 5 billion downloads of his open source libraries, and he's a member of the Node.js Technical Steering Committee on Streams, Diagnostics, and HTTP. He's also the co-author of the book Node.js Cookbook. It's the 3rd edition. Tayar has a huge amount of conference speaking experience and always speaks with a huge amount of enthusiasm. So now he is going to answer the question, can we double HTTP client?
Hi, everyone. Hello. Sorry, last minute hiccup. I don't know what's happening with my headphones. They keep going away all the time. Anyway, I am back without headphones. Hopefully it won't interject too much. Cool. Okay. Hi, folks. Hi, Katie. Thank you for having me and for the nice word to introduce me. Hello. Great. So hopefully you will be starting to hear me. You will hear me fine. Quick question. Is the screen sharing going? I can't hear you if you're speaking, guys. Yeah. Okay. Perfect. Yay. Okay. Amazing. Thank you, folks. Hi, everybody. I'm Matteo Collina at Matteo Collina on Twitter, and I'm here to talk to you about the HTTP client, which is pretty interesting piece of thing inside Node.js, inside every Node.js application. So first of all, let's talk a little bit about me. I am a member of the Node.js Technical Steering Committee. I created a couple of nice libraries called Fastify and Pinot. I am also doing software architect for most of my careers, and then a consultant at NearForm, which I am also a technical director of, similar to Katie. So here we go. A little fun thing about me, my modules are used quite a lot. I maintain a significant chunk of the ecosystem. These are projected 5 billion downloads 2020. It's mind blowing. Lot of responsibilities. So this is to show you the duality of my role. I help companies building fast and scalable Node.js application on one side, and on the other side, I help companies maintaining. I help the Node.js project, and I maintain a part of the ecosystem, which is pretty cool, really nice. So, and it's this kind of balance. It's always how much should I help companies and how much should I do maintaining Node.js and its ecosystem, and where can I leverage my learnings as a consultant to improve the ecosystem? Well, I tend to do this all the time. It's kind of a virtuous circle that I've been at for the last few years. So here we go. One of the clear architecture that you can go for the web is to have a monolith application. So you have a client, you have some link to the cloud, and then a server. This client can be a browser or a mobile app or whatever. And you have this is a monolith because it's only a single block. Cool, right? It's just one single thing, one single server, or well, more servers, but scales horizontally. It's one single code base. This is the typical, what is called a monolithic approach. It's a monolith. I have been working a lot in how we improve Node.js servers over the years. And one of the fastest, I created Fastify for this exact same purpose, to be one of the fastest web framework for Node.js, but also have a very, very nice developer experience. And you can see that it's all like modern stuff. And it's also downloaded a lot. It has a lot of collaborators, and it has a thriving ecosystem of plugins that you can use about it. Pretty nice. But you can use Node.js to build a monolith, and then what happens if you want to scale teams? Now, we have been on a long debate recently on Twitter why microservices, and microservices are in fact a great way to scale teams, which is really, really cool. In fact, I can take some responsibilities and divide it into multiple microservices, which will lead to, can be managed by multiple different teams, which gives us a huge, which gives us benefits, because then I can have multiple people working on things multiple times. Now, when I have too many people working on the same code base, nasty things start to happen, so you might not want to do that in the first place. Bunch of nice. One of the problems, though, about microservices architecture is that, well, you wanted to do this, right? You have a gateway, and then you call a bunch of microservices. However, as soon as you start building microservices, you want to really reuse the other microservices to build more microservices. So you start having like internal microservices that are only there just to serve and share data between like the ones that are like top level ones. So, and you see that there's a lot of chattiness between the microservices. You have internal links between the microservices where they start talking to each other. Now, one of the greatest language that you can use for doing that is HTTP. And you can also use other things like gRPC, but it's, or something custom even. But HTTP is a great solution because it offers greatest traceability. You can use something like open tracing and other things to trace things up. Well, the problem is, like, I focused a lot on improving the actual node, the actual server and the serving of a request. I found that the link between the microservices become the next bottleneck. So how fast can we fetch data? Can we retrieve some information from some other microservices that can be listening on the next route? So I started wondering, how can we speed up the link between two microservices or various microservices? Well, let's start with a very, very simple server. It's a server that returns and it has a nice timeout. So I have used this as the basis for my benchmarks. So, you can configure it, depending on what you want, you will get a response after those amount of seconds. Now, you probably have seen the HTTP client of Node.js a lot. You have seen you get and you do http.get to do it, to do an HTTP call. You can pass some variables here, some options in there. Then you get your response, which you need to pipe to a destination, and then you can do something with the events. This type of, using this API, do a new TCP socket for each HTTP request. So it creates a socket, sends the data, close the socket when it's done. And it's also the basis of Axios, Node Fetch, Request, GOT, and so on, and all of them, essentially. So if you are using all of those without any specific settings, you are using this type of pattern. It creates a new TCP socket for each TCP request. Cool. Now, note that creating a TCP socket, it also requires a little bit of a round trip, okay? So essentially, you got a round trip. Note that these are taken from this book. So you can see the book at the top. I will talk about books later on if you're interested in this topic. And so this is kind of interesting because when I create a socket, means that I need to allocate something on my sender of my operating system, which will send an IP packet, a TCP packet with SYN to the receiver, which will do some other stuff, allocate it, call your Node.js, and so on and so forth, and then we'll return a SYN-ACK, and then you will return an ACK in here with some application data. It's also this system. It's also the basic of what is called TCP connection window. So if you are creating a new connection every single time, you have you enter this. What happens is that you start opening a connection. You start getting the request. The request is processed, but then the request is segmented into multiple round trips between the server. And know that this takes some time. Now, the key problem here is, and where you want to, one of the key problems is that this happens because TCP has what is called a congestion window. It's built to minimize the probability of packet loss. And it's the greatest features of TCP and why you can use TCP everywhere to do everything on the web. However, and it can work from a very, very fast connection with fiber to something very, very slow, like a 28,000K baud modem. So it works on both of them, right? Note that if we keep reusing the socket, though, you will only get your answer in one single round trip, just with minimizing the latency. So if we want to ensure maximum bandwidth, we must reuse existing connections. And this is a given, okay? Remember this. If you want to ensure maximum bandwidth, you must reuse existing connections. How can we reuse existing connections with Node.js? Well, we can, and we need to specify this agent here, which you see that you want to use a keep alive connection, which means keep the connection alive, and you want to specify a max number of sockets. Now you need to really set these, otherwise things get really weird into resource allocation on your system, so set a maximum. And this is one of the key drivers of performance on this type of system, so be aware. Note that this is even more important with TLS, because if you are running this with HTTPS and less with TLS connection, you are in trouble if you're not setting an agent, because otherwise you will keep recreating a full TLS context every single time, which is, again, very, very problematic. So please keep in mind and set up an HTTP agent everywhere. Let's turn Can you still hear me? Okay. The client calls one server with 500 parallel requests, and it's so this means that it has like 5 outbound requests for each inbound request, which is equal 100 parallel inbound requests at any given time. And it's the timeout on the server is configured for 10 milliseconds, and the client has a limit of 50 sockets. Okay. Note that the benchmark here are really dramatic. The improvement of the agent with Keep Alive is dramatic. So this is 80, by the way, 80, close to 4,000. So the improvement is dramatic. So always use an HTTP agent. You can configure the HTTP agent in a sort of bazillion ways. So check out the library that you're using, use an HTTP agent right now. Now, okay, this is the status of things. So if you're not using it, can we improve things more further? Maybe. Let's see a couple of things. So first of all, one of the key techniques is HTTP 1.1 pipelining. HTTP pipelining is a technique that allows you to send multiple HTTP requests inside the same TCP packet. And this enables you to do the processing in parallel on the other side. So in Node.js, you can do the processing of the 2 requests in parallel. However, the response for those needs to come in order. Node.js HTTP client does not support pipelining, unfortunately. So how can we use this? I don't know. Well, I just want to mention one problem of this. It's head of line blocking, which is kind of one of the biggest problem for this type of solution. It's because of head of line blocking, a slow request can block the processing of our system. Now, head of line blocking is a kind of a topic that was born on top of TCP networking. So in TCP, if you are transmitting multiple TCP things, TCP packets, if a TCP packet is lost, all the messages that needs to be retransmitted, because all packets needs to be received in order. Now, this means that if we, in this case, if the first request is slow, then the second one needs to wait, which is kind of a big problem if you have very slow routes compared to very fast routes. So keep that in mind. Also, let's talk a little bit about the event loop, because this is our big friend. So whenever if you are executing some JavaScript, you are doing some I/O, you want to schedule some I/O to happen, so you schedule some I/O, and then when that's done, it puts an event in the event queue and goes back in. Now, the following slide is part of our Broken Promises workshop. So let's dwell a little bit on what happens inside that single event loop phase. So you have the event loop. You have the event loop that is running. Decide that there is an event for JavaScript. The event loop calls into some C++ inside Node.js, goes back into the JavaScript function, which is your code. Once that is executed, it processes all those next tick promises, you blah blah, stays there for a while, then returns on the event loop. Now, it has some very, very important definitions, because this is very important because in this type of system, minimizing the time the event loop minimize the time the event loop is blocked is the key strategy to increase the Node.js throughput. So if you see in here, you see that this time the event loop is blocked. So if we want to keep doing I/O and doing fast I/O, this phase needs to happen very, very quickly. So I started working on this topic, and I've built a new HTTP client for Node.js. This new HTTP client is called Undici. Well, why Undici? Because you have HTTP 1.1, 11, which is 11, which you call it 11 in the number. However, 11 on NPM was taken, so 11 means Undici in Italian. Note that Undici, so at the point of when I started working on this, the strangest thing happened. So, you know, this is kind of a clear reference to it. So here you go. Not that this type of picture actually makes sense for Undici, but whatever. Anyway, with Undici, you can create a pool of connections to a given host. So you specify the pool and you put in the host here. Note that it can also have a single client API, which works exactly the same. Then you do a request to the pool, passing a slash and some other blah, blah, blah. Well, this is a bad copy and paste on my side. And then you do resume and on end. Now, you can also use a lower level API, which is actually way, way better in terms of performance, which is stream. Stream actually let you return the right stream where you want to write your response. In this way, we can avoid a little bit of overhead in your code. So it's actually pretty nice. And actually very easy to use. It's a little bit less forgiving than Node Core HTTP client. But please check it out because it's amazing. So I love it. Let's see how Undici compares to Node Core. Well, we have HTTP with no agent, HTTP with agent. Undici request, which is very similar to HTTP no agent, to be honest, is a little bit better. But you see, you still want to have the keep alive and reusing of the sockets type of thing. You see that there is Undici with pipelining. So it's still using a single connection, but not a lot. And with pipelining, it's actually getting a lot of, it's actually improving the efficiency of the single connection, but not as much. Undici with a pool, slightly better than HTTP agent with a keep alive, but if you enable pipelining, it kabooms over 3 times the throughput of Node Core, which is pretty amazing from my point of view, with all the caveats of head-of-line blocking and so on and so forth. I've also done some other benchmarking, and I know my friend James Nell will probably won't like this, what I'm going to say. So I have used this module called Fastify HTTP Proxy, which is a library to build gateways using Fastify. Again, Fastify is one of my turfs, so I'm using that. Shameless plug. And I am going, so it's using for proxy requests. It can do body and header manipulation, authentication. You can put whatever you want in here. It supports various modes, so you can use HTTP1 with HTTP1, HTTP2 with HTTP2, HTTP1 to HTTP2, and HTTP2 to HTTP2 101. I've done some benchmarking with HTTP2 to HTTP1.1 to HTTP1 or HTTP2 server. And turns out that this is Node Core with an agent, and this is Undici. You can see that the gap is pretty much, there is a lot of that can help a lot with the throughput. Note that it's also slightly better than HTTP2 with one single connection. I think we are hitting at this limit. We are hitting, HTTP2 is fully multiplexed. So it's reusing some. So it enables you to run multiple requests in parallel over the same socket. And I have a feeling that this is happening because we are maxing out some operating system resource, some internal operating system resource that prohibits us to reach higher values. Anyway, TLDR from this talk, what you should remember, always use an HTTP agent, okay? Always do that. If you don't do that, bad thing will happen. It's probably the biggest bottleneck of your application. Note that Undici can also drastically reduce the overhead of your distributed system. So check it out. It's actually pretty interesting. And I also want to thank Robert Nagy that took Undici from that work that I started and brought it to the greatest status that it's right now, which I'm really proud of. So thank you, Robert. We also need help. We also need help. So we also need a lot of help. So you can take Undici, and you can take Undici. You can use Undici to build higher level clients with Undici, like Fetch or something like that, and so on. Before we finish, I wanted to talk a little bit about a fantastic book, which is by Ilya Grigorit, which I've taken some of the slides from, some of the images from. So high performance broken networking, and it's available online for free. You can also buy the book, but it's also available online. So given that it's available online for free, read it. It's a must-have if you want to do any performance work on the web, and it's really, really important. You can also check out Fastify, fastify.io, here you go. And there is Undici, of course, which is, you can find it on the Node.js repository /Undici. And a guide on the event loop if you are interested on that. And finally, a little thing about Node Clinic if you're interested into learning more about flame graphs. Having said that, I would thank you all. I'm part of NearForm, so we are a professional services company. You've heard Kian and myself blabbering at the beginning of the conference, so rambling a little bit. And I would, if you need anything from, if you need somebody to help you for your Node.js performance problem, to your Node.js development, JavaScript in general, whatever, give us a ring. We will be very, very happy to see if we can help you. Please feel free to reach me at Matteo Collina or at matteo.collina@nearform.com.
Okay, thank you, Matteo. That was an excellent talk. It's really, I've got some questions for you, but I would also like to remind people that if you have any questions, could you put them in the Slido channel? So there's a Q&A point you can use, but there's also in the chat. So if you put anything there, we can pick it up for you. So I'm going to move on to the first question. So we've got a question from Bjorn. Bjorn has asked, Matteo, how do I find the correct number for the max? How do I find the correct number for the max sockets? And is there an easier way to calculate or some sane defaults?
This is a tricky one, okay? I love tricky questions. The easiest way is to benchmark, and this is the bad way, okay? You can go and, so if you put in the wrong number, it's not super bad. So you can, if you tune that number correctly, you will see a great spike, and you will be able to handle a lot more throughput. It's kind of a balance because you want a little bit of queuing of your request, but not too much. I would more or less increase it up until it gives me any benefit on my production system. So that would be my typical rule of thumb. I typically start with like good numbers are maybe 25 or 50, and then you can go up. Note that every socket that you allocate will consume between 8 to 64 kilobytes of RAM on your system. So if you have 1,000 allocated for your agents, keep that in mind, and so on and so forth. So creating sockets actually has an impact on your operating system. So that's it.
Okay. So Brian's just come back with another question as well. So Brian says, nice. Will Undici for HTTP2 be called Due or Verti? Oh, people, they're just trying to get me to pronounce things wrong, especially to the Italian. I'm sorry, Matteo.
You see, that's why I call my libraries with names so people can get in trouble. So no, it won't be called Venti. It's I don't think there is a need for Venti in Node.js. It's I think our current HTTP2 API are pretty nice and pretty performant already. So I don't think there is anything to be done there. There might be some work done and to improve those API, make them more performant, make them more compatible, make them easier to use.
Okay, thanks. I'm afraid we've run out of time for questions. So
no,
thank you, Matteo.
reach me out on Twitter, okay? At Matteo Collina. Follow me and reach me out on Twitter if you have any questions. Thank you.
He's always on Twitter. He will be there for you. So we couldn't run NodeConf Remote without our sponsors. So a big thank you to NearForm, partly for letting us have Matteo today as well. But thank you to NearForm, Microsoft, Bloomberg, Red Hat, and IBM. And here is a short film about IBM now. And we'll be back with Anna Henningsen straight after.
Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative. Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative. Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative. Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative.
Hello and welcome back. And so next up, we've got Anna Henningsen. So Anna is one of the most active contributors to Node.js Core over the last 4 years. She is fueled by a passion for Node.js and its community, and she's recently become a part of the MongoDB developer tools team. She's been active using Node since about 2012, which I can't believe because she certainly doesn't look old enough. And she is my hero. I've seen her do more successful live code demos at conferences than any other speaker. I did find a little quote from her online in the past where she did say, the most fun talks I've ever given are about live coding and implementing features in Node.js. So I suppose that makes good sense. Anyway, all the way from Dusseldorf in Germany, please give a warm welcome to Anna Henningsen and Node.js and the struggles in EventTarget.
Okay, hi everyone. So first of all, no live coding today, sorry. I'm Anna. I'm a software engineer at MongoDB, joined the company in September, so that's all still pretty fresh, and I'm not going to be talking about any MongoDB stuff. You'll see my Twitter handle at the bottom here. I posted the links to the slide for this talk there as well. And yeah, so let's get started. So if you look at these things you recognize in a lot of these names probably, but what do they all have in common? You can tell that most of these are things that seem familiar because they are global variables in the browser or Node.js. And in fact, it's all web APIs that Node.js adopted at some point in its life. And that is a move that Node has been making towards using more web APIs. And in fact, a lot of these are still pretty fresh. I highlighted the ones that are just from this year. So it's all moving fast towards browser knowledge. And one thing that I want to look at in particular here is EventTarget, because it's kind of a fundamental building block of web APIs. So for example, a board control and message port, they are EventTarget instances. So like they use that API to build and extend it. So yeah, why did Node not have that in the first place? Let's look at how the two of them differ. So there's EventTarget, there's EventEmitter, and you can use them in very similar ways. So something that is called add event listener in the browser is called .on in Node.js. Dispatch event is called emit, but in the end they kind of do the same things, and it's like very similar APIs that perform very similar use cases. So you use add event listener or on to register a function with this object and use .dispatch event or .emit to call that function. It's basically a way of splitting up the call side of a function from where that function is defined. In the web, you can use one additional way of registering this listener, which is this fake property kind of thing. So you can use .onClick instead of .add event listener click. Sometimes that's a bit more convenient. It won't fit every use case, but you can do that. Let's look at why we have this distinction. When EventEmitter was added in the first place, that was like June of 2009. Node was very young at that time, and there had only been 2 contributors, one other person besides Ryan Dahl at that time. And things were just added in a very ad hoc fashion. So it was not necessarily even a goal to add something that would be browser compatible at some point, just something that worked. And there are some technical reasons to not use EventTarget in Node.js as well. There are some browser concepts that just don't apply to Node.js. If you click on an element of a web page, that's kind of also a click on the surrounding element, and it's also a click on the whole page. But in Node.js, you don't have that kind of thing where something bubbles up a tree. Just isn't there. So there are some differences between what the browser needs, what Node.js needs. And what ended up happening is that we came up with something that is kind of like EventTarget, but not quite. And that's never a great situation to be in. Having 2 APIs that perform similar functionalities, but look slightly different. Right. Let's take a step back. As you may know, we added workers to Node.js. As you may or may not know, workers use message ports for communication internally. So this is a web API, the message port one that we try to follow as closely as possible. Workers were introduced in Node 10, but in the browser, message port is a subclass of EventTarget. Event was added this year, if you remember. So it was we added it in Node 14.7 and started exposing it to users in Node 15. And that, if you think about it for a second, that's kind of weird. How did we end up using an API that was not there in the source code? Well, the answer is that we didn't. What we did, or more precisely what I did, which I am not feeling great about, but I also wouldn't know why I did it. So what you could previously do with message ports in the past in Node.js, you could use event emitter style listening and some of the web style listening. So you could use .on with a message argument and a listener, and .on message as you would have in the browser. But you would not have the full EventTarget API available, which is unfortunate. But at the same time, so I did in the past not want to make workers support in Node dependent on adding EventTarget. Because when you do add a feature like that to Node.js, there's going to be a huge discussion every time about how we do it, how we expose it. And I wanted to get workers done. So that is kind of like how we ended up in this situation. Well, it would be nicer if we could also use it in a fully compatible way, where we use EventTarget. And this talk is basically the story of how we got to that point. What we changed in Node 14.7 was previously message port inherited from event emitter and kind of also inherited from this other thing. I'll go into a bit more detail on that in a second. But the important thing is it inherited from event emitter, and what we then changed is we made it inherit from like an internal node class that is kind of like a utility. It's called Node EventTarget, which inherits from a proper EventTarget class, but it also provides hooks that are very similar to the ones that provided by event emitter, so that you could essentially keep using message ports the way you used them before. That was kind of important to us because we wanted to like have compatibility after we released it in a minor release of Node.js, not the super major one where breaking changes would be expected. Well, one thing about that, so obviously this changes the inheritance hierarchy. It's previously message ports were instance of event emitter, now they're not anymore. And now they're instance of EventTarget. And we were kind of like, or I was kind of like, well, this is okay because people are not really used to checking instance of something. They're used to using the methods on the object that they can use. That is the important bit. I really thought so. After I finished the slides for this talk, just last week, somebody opened an issue with this title. Parent part extends EventTarget in Node 14, but extends event emitter in Node 12. Turns out we did break it in some ways that were not quite expected. And you can look at this issue in more detail if you want. But basically, we did not port over a .emit function from event emitters to this internal Node EventTarget class because we didn't expect people to use it. Because why would you emit custom events on a message port? Sure, you could, but why? Well, there was some misunderstanding about how .emit error works on a message port. And this change that we made exposed that misunderstanding. It's not really a bug on our side, but it's still unintended breakage. So we're in the process of fixing that right now. But anyway, so going a bit more into detail on that, multiple inheritance is kind of a weird thing to do in JavaScript. So in JavaScript, you can only have one superclass for each class, or one class that an object inherits from. In the case of message ports, so message ports are transferable objects. What that means is that you can use a message port to transfer a message port to another thread or whatever is on the receiving side of that channel. They're not the only examples. For example, by now you can also transfer file handles and array buffers. So you can move objects from one thread to another, for example. In order to make that happen, the V8 API that we use for serialization and deserialization in .post message, that requires these objects to be implemented in C++. Well, when we added EventTarget, we added it as a JavaScript class, as an ES6 class to our source code. And that's kind of tricky because C++ classes cannot inherit from JavaScript classes easily due to the way that V8 models native C++ backed classes. So what did we do? Okay, apparently there's some kind of message that I'm not seeing that should be in. I don't know. I'm sorry. Yeah, really not sure. Anyway, I'll just go on with the talk. So yeah, how do we solve this? So there's an obvious brute force solution to this problem, which is if we want to inherit from EventTarget and it cannot be a JavaScript class, we could implement it in C++. That's what browsers do, and they are just fine with that. But well, I also heard somebody say a couple of weeks back that browsers are kind of like C++ engineer employment programs, and Node.js is not. We want accessible and maintainable and fast source code. And to the vast majority of Node.js users, C++ is not a very accessible or maintainable language. And the fast point is more, so when you have calls between C++ and JavaScript where you jump back and forth, it gets kind of expensive. We did not want that overhead. So what's the alternative? We can look at how we did this before, because if you remember, message port inherited from event emitter. So what you can do with old style classes, like from before ES6, when you started using the class keyword in JavaScript, what you could do is you could essentially take an object and turn it into an instance of a class. It's not something that you would usually do, but if you need to, it works. So you can create any object, use eventEmitter.call to make it, like, take the constructor and call it on an object and just let it pretend that this is not already an event emitter. And you set up the prototype change so that all the methods are there, so that .on, .emit is there, and so on. And then you can actually use those methods. So this example actually runs. This is what we did previously. Turns out this is not that easy to do in this case. So EventTarget, we implemented that as an ES6 class. And calling that as a function is not allowed. So this would not work. The EventTarget.call would just throw an exception, and it's not going to work. But we can still kind of follow the same approach. Oh, right. There's a talk tomorrow by Thomas Watson about JavaScript prototypes behind the scenes. If this is interesting to you, that talk is probably going to be interesting to you as well. But yeah, anyway, we can kind of take that same approach. This is actual excerpts from the Node.js source code. What we essentially did do is we took the EventTarget constructor, we put all of the source code that was inside it into a separate function called initEventTarget, and then that function we could call a new object. So for example, for message ports, we set the prototype change so that it looks as if there was a ES6 class message port in extends NodeEventTarget kind of thing, even though it isn't really there. And we use this onInit function that is called from inside the C++ message ports constructor. And it calls this init function that sets up all these states that should be there. And there's also a to-do in that function that if you're interested in working on this kind of thing, feel free to ping me about that. Yeah, so this is how we solve that problem. Then, if you remember from the earlier slides, the way that I can actually show this. Right, so the way that you access data from event listeners in the web style API, you get an event object. Node.js event emitters, you just pass in some arguments to emit, and the listener gets those arguments as arguments. In the web, you always have this event class, and you only can pass events as arguments. That turns out to come with some performance implications. So when I first opened a pull request that did this, that moved message port from event target to from event emitter to event target, there was like a 50 to 75 performance drop when we ran the benchmarks on that. That's not good. I mean, that's 4 times slower than it was before, which you don't really want that. What do we do in that case? So what we did end up doing, is we profiled the benchmark that we ran. So in this particular case, we generated a flame graph. I'm not a graphic designer. I just took a red toned issue with white background and inverted it so that it fits into the dark theme of this dog. I don't know, the colors might seem a bit weird, but that's not the main point here. The point is that in this thing, you can see that the event constructor of this event class that gets passed to the listeners, that takes a really long time. So like it looks like it's almost 50% of the entire benchmark runtime, just this constructor. And so there are 2 things that stand out if you look at this in detail. One is there are these 7 peaks to the left that all kind of look similar. And when you look at what the stack traces actually say there, what's happening is that you can see it's setting private properties. And you can actually count the number of private properties that event instances have. And that, I mean, that just is not optimized in V8 yet, or at least it wasn't at the time when we added this. I mean, that's just the way that JavaScript features work. They are not optimized in the beginning. They are added so that they work, that they perform to this, conform to the specification, but they're not fast in the beginning. So that was one thing. The other thing is like this big chunk, which is essentially just an object.defined property call that was also very slow, that we did not want to do this way. So how do we solve these things? So for the private properties one, that's easy. We didn't stop using private properties, started using symbol properties instead, which is basically almost close enough to what we want. Right, so that we did, this is not actually part of the PR that I opened. This happened because something else that we did ran into private properties as well, for not performance reasons, but still. So anyway, this already solved a lot. If we do this and get rid of that object.defined property call, we actually speed things up a lot. We only have 20% performance impact left if we do that. So like a relative plus 75% improvement on the benchmarks. But let's look at that object.defined property call in more detail. Oh, one thing before. So I have an opinion about private properties. This is not my current employer's, not my former employer's opinion, not anybody on the Node.js team, obviously not TC39's, not the conference's opinion. I would not use private properties. Not because of performance reasons. I mean, at some point, JavaScript engines are going to optimize them. That's not a question, but I don't think they fit very well into the model of how JavaScript objects are supposed to look like in the thought model that you're supposed to have of them. So if you don't like them either, feel free to not use them. If you do like them, Okay, it's not like I could stop you. But sorry for the jump. Let's look at this object.define property call. So there's this isTrusted property on event instances that is, according to the spec, an own property and a non-writable, non-configurable one. And that is kind of unusual. What it essentially leads to is the fact that this property cannot be overwritten in any way. Like you cannot change on the itself, and modifying it anywhere in the prototype chain won't get you anywhere either. This is unusual. You don't usually do this. And it turned out that this was really slow, as you saw. And I mean, there were ways to get around this. We could have moved it to the prototype or something and have it be forgeable. But the name isTrusted, and the fact that it's spec'd this way kind of made it seem like there were security implications to doing so. So we decided not to do that. If somebody wants to come talk to me and tell me what the exact security implementations of isTrusted are, feel free to do that. I did not find a lot of information on that. But anyway, so I was kind of stumped. How do we progress from this? How do we make this faster? There's a good solution for that, especially if you're me, which is you go to Twitter and you ask people partially people on the V8 team, because that is where this is implemented. And that actually helped. So Tone, who's on the V8 team at Google, he basically gave this advice that there's this trick. So in the previous code, we always created a new get function, but if we don't do that, it's going to be faster. We did that. We moved this isTrusted getter out of the class, changed it so that it will always be the same function and not a new one every time, even though the source code will be the same. And it was like a 200% performance improvement on the EventTarget benchmarks. So like 3 times as fast, which was nice and surprising. I learned something that day. But yeah, so where does this get us? In the end, we still had 30% slowdown. That's probably not okay for a Node.js feature to slow down that much in a Semver minor release. And in the end, that's because event instances are just not plain JavaScript objects. They have custom properties. They have their class instance. They're just not free to create. And another thing that I learned over time while working on Node.js from the V8 engine is that sometimes it makes sense to have a fast path and a slow path. And the fast path can be fast, and if people start using something that triggers the slow path, then they just have to live with that. It's kind of what we did. So if nobody actually uses the EventTarget style listeners, we don't need to create event objects. We can create them on demand once there are such listeners. That is the approach that we eventually took. And in the end, so the event emitter style benchmarks did not show significant performance regression after that. And if you look at the difference between them, if you use the EventTarget style API, you get like a 30% slowdown in the end. So originally we started out with a 75% slowdown. Then we tried to optimize it. And in the end, we had a 30% slowdown that was still remaining, not quite as bad. But it was fine because this only affects people who use the new style API, the event one that was added in that release. So on a final note, people don't really care about performance as much as they think they do. They don't care about fast APIs. They're just happy to see like these numbers. If something is like plus 200% faster, that's always yay. But whether that actually affects the performance of their application as a whole, probably not. So Node.js is not always good about seeing that as a big picture. If we had started out with MessagePort as an EventTarget style API that was as slow as my original port would have been, everything would have been fine. Nobody would have complained. People just don't want things to get slower, which is fair, but yeah. So yeah, MessagePort is an EventTarget since Node 14. We added several EventTarget related globals in Node 15. There are links to the relevant PRs in the slides. This is based This talk is mostly based on a blog post that I wrote a while ago with some current updates, but still, if you want to read about this instead of listening to me talk, that's also a good resource. If you want to ping me about the to-do that I showed a while ago in the slides, feel free to ping me on Twitter or something. And I have uploaded the slides and posted a link on Twitter. And that's it. Thanks for listening. I hope you enjoy the conference.
Thank you, Anna. Thank you ever so much. That was amazing. I've just been told that I'm afraid we don't have time for questions for Anna, but if you have any questions, you respond on Twitter pretty well, and so talk to Anna through Twitter. Thank you again. So next up, we've got another word from one of our sponsors. We're going to hear from NearForm, and it's going to be a special treat for you all. This is going to be a stretch break with Rasheen from NearForm. She is going to take you through some good stretches because you don't want to be sat down at your desk all day, not moving. So over to Rasheen from NearForm.
Okay, so let's get started on our 5-minute desk stretch. So we're going to sit in our chair with our feet flat on the floor, sitting up nice and straight. Try not to hunch in as we do all day. We're going to start with a little stretch for our necks by bringing the left ear towards the left shoulder. Again, just remembering to keep the spine nice and straight here and draw that shoulder down. Breathing. And back to center, and we'll do the same on the right hand side. So right ear towards the right shoulder, drawing those shoulders back and down. And back to center. So now we're going to bring the chin towards the chest, looking downwards. Sitting up nice and straight. And releasing, and the opposite way as well. So we'll raise the chin towards the ceiling. And we'll come back to center, and now we're just going to look to our left. And inhale back to center, and again, look to our right. And back to center. So from here we're going to go into a nice side stretch. Bring the right arm up and grab the left wrist, really stretching up, elongating the body and keeping our chest nice and open as well. So we're going to inhale, reach up, and exhale to the right hand side. Just gently pulling that left arm as well if we want to get a deeper stretch. Really opening up down the side body and through the rib cage. One more breath. And release, and we'll go to the opposite side. So again, we're going to stretch up with the arms. Inhale, grab the right wrist with the left hand. Stretch up and exhale, bending to the left hand side. And back to center, release the arms down, and we're going to go straight into a seated twist. So you can put the right hand on the left leg, the outer left leg, and bring the left to the back of the chair or just to the bottom corner of the chair here, depending on what's available to you. So we're going to inhale, straighten that spine, and then exhale, twist. Sitting up nice and straight and keeping the core engaged here to protect the spine. Take another breath. And you might deepen with the exhale. And back to center, and again to the opposite side. We take the left arm to the outer edge of the right leg, straighten up. We'll bring that right arm back the chair or just down to the corner of the chair. Going to inhale, up nice and straight, and exhale, twist. Inhale, straighten, and exhale, and release. So for our final stretch, we are going to bring the chair just out in front of us. We're going to have our feet hip distance apart, and we're going to do our supported forward fold. So we'll hinge forward again from the hips, reaching the arms out over the chair, and just letting our head and chest really hang here. Feel a nice opening across the chest, stretch into the shoulders. When you're ready, you'll slowly come back up, pushing yourself up and releasing back to standing. From the arms up overhead, take a nice stretch, and palms down through center. And we're finished.
I hope you've all had a good stretch and are ready for the next session. So we have Yoshua Wuyts, and Yosh is an engineer at Prisma, a former Node hacker and currently active in Rust. He used to maintain a browser framework in JS. He has done a fair bit of work, and those were his quotes, on asynchronous both in Node and in Rust. He has 2 cats, which I have discussed with him at some point is the optimal number of cats, and he lives in Berlin. So please welcome Yosh with WASM, Rust, and you.
Hey everyone. Thanks for the intro.
You're welcome. I hope your cat comes on screen with you as well.
We'll have to see. I hope so too. All right. Oh, yay. Okay, I guess I'm on. Hi everyone. My name's Yosh, and my talk today is. Oh, slides are not on. Okay, sorry, I'm a little bit all over the place. Yeah, my talk today is about Rust, WebAssembly, and you, in which I hope to make WebAssembly a little bit more practical for people who are interested in it. Yay, cool. Can people see my slides? Right. Anyway, my name's Yosh. I work as a Rust engineer at Prisma. What we do is we build a variety of database projects to help make database access nice and friendly in Node.js. You can try it out. It's on NPM. And we also have a website, Prisma.io. But that's not what we'll be talking about today. Today, we'll be talking about Rust and WebAssembly and how to put them together. And we'll be making things that kind of look like this. Just, the regular old 2015 demos, hello worlds, that kind of stuff. But yeah, more on that in a sec. Right. So before I dive in all the way through, I know I'm talking to, I'm guessing, majority Node.js audience, which means if I start talking, like laying down all the Rust and WebAssembly terminology on you, you might be a little bit confused. So let's get through the basics first. Right. So Rust, that's a general purpose programming language. You can build it to build very low-level things like operating systems, browsers, compilers, that kind of stuff. But also very high-level things like web servers, or in this case, I'll be showing you some browser fun. Right. Next up is Cargo, which is Rust Package Manager. It's kind of like NPM, but for Rust. Differences are not too big, I think. Then there's Cargo TOML, which is the package manifest format, kind of like your package JSON for NPM. Then there's WebAssembly, which is like portable bytecode. So if you're not familiar with bytecode, it's like when you have JavaScript, like the text format, you can run it through like a minifier. So you have like a smaller version, you head over to Y, send it down to like either the browser to like V8 compiling engine, like optimizing engine, which takes that representation, parses it into an AST, then like starts optimizing it and creates bytecode and like does all the fun stuff with that. So like the low level, not quite machine interpretation, but a little bit above that. So not quite assembly, but right above that. WebAssembly is much like that V8 bytecode internally. But instead of being like V8 specific, it's a portable format that's actually spec'd out and like can run in pretty much any environment. So it's kind of nice like that. And different languages can compile into WebAssembly. So Rustlang has a backend through LLVM that can compile down to WASM, which can then run in a variety of environments. WASI is another term that you might like here, which stands for the WebAssembly System Interface. In Node.js, you might be familiar with libuv, which provides cross-platform system bindings. In WebAssembly, there's a kind of like a libuv-like abstraction, which provides cross-platform system bindings specific for WebAssembly. And that's called WASI. It's got some nice properties around security, portability, upgrade stuff. It's quite nice. I might get into that a bit more if we have time. Finally, there's the WASM host, which is the environment that WebAssembly is executed in. You can kind of break it out into three kinds, which is a standalone environment. So imagine you have a WebAssembly program, just the bytecode, right? And you can compile that down to an x86 binary for, say, Linux. And it does all the checks like ahead of time. It compiles it all the way down, and now you just have a regular executable that just works. The second variant is a virtualized standalone environment, right? So you take a WebAssembly program, and you have some sort of like small VM that just executes that directly on some host, which is when you're like dealing with untrusted code or, but yeah, there's no like bigger runtime environment wrapping it, which is the embedded variant. So say if you're executing WebAssembly code in the browser, or you got a game engine that says like, hey, I've got this little extension part that is a WebAssembly engine, then that's part of a larger system. That's more or less the embedded use case. And we'll be focusing the third kind, embedded, specifically towards the browser. I want to make it a little bit more practical so you can kind of see what that looks like. All right, so to get started with Rust WebAssembly today, first you need to install Rust. The way to do it is use winget or Homebrew on Windows or macOS, and you install Rust up, which is kind of like NVM, but for Rust. By default, also installs Rust and Cargo and all the other things for you. On Linux, depends on your operating system, but there's a script on the Rust website to get installed. Then second, you need a WebAssembly toolchain, because currently when you compile Rust to WebAssembly and you want to interact with like a host environment, you need to generate some Rust code, but you also need to generate some JavaScript code. And WASM tool helps you that. So you need to install that. Cargo install is like npm install -g, so like global. Then the third step, I guess, is create a new Cargo project. It needs to be a library project for reasons. Cargo has a initializer built in, so you run Cargo new. And finally, you create a little HTML file, which includes a script tag of type module. And from there, we just add this little boilerplate, which says import init from my package. So example.js, change to the name of your example thing. And then you initialize it, pointing it to the WebAssembly file. And that'll like get you going. So time for hello world. When we talk about a hello world on the web, you might think about something like this, which is a little body tag, right? which is always there. And then inside of it, you initialize a little paragraph and you say, hello NodeConf. So in JavaScript, the way it's done is by running document create element to create a new paragraph tag. On that, or separate from that, we create a new text node to fill in the contents of that paragraph tag. Then we insert the text inside of the paragraph tag, and then we insert the paragraph tag inside of the document body. Right. Then in Rust, with a library that we're introducing today, you can do much the same. So to get started with Rust, Rust always has a main function. In this case, we have an async function main. Needs a little attribute for it for this to work. Don't worry about that. Prelude is a common glob import to make stuff work. Don't worry about that either. It's pretty common. And finally, we, from localGhost, which is the library I've built, and you'll be seeing more of throughout this presentation. This presentation, so formal. You can import the DOM submodule, and you can get element kind, and start creating tags. So in this case, we say create a new tag of kind paragraph, and inside of it, we add a little text, hello NodeConf, and then we have a paragraph tag, which corresponds one-to-one to an actual DOM paragraph tag. And then we select the body from the DOM, and we append the paragraph tag, which, if you squint a bit, is pretty similar, right? All right, great. I sure hope so. I can't read the comment right now, so hopefully everyone's like, yes, that's very similar. Then in order to compile this, we run WASM pack build, and we give it target web. By defaults to webpack. Yes, webpack. Sorry, I forgot the word. But yeah, we give it target web, and it compiles down. And then we have a hello world. Anyway, time for localGhost. So what is that? Why does it exist? Why do we need it in Rust? Right. So this is the document, the docs.rs page for localGhost. Caro comes with a documentation tool. It's quite nice. This is the overview of the package as it stands today. You can check it out, because I published it 10 minutes ago. Anyway, so the layering for Rust on the web works is more or less, at the very bottom layer is the web platform itself. So all the APIs that the web exposes. On top of that, there's direct bindings to those capabilities. The web platform is specified using meta language called WebIDL. And in Rust, we can generate direct bindings to that. Not the nicest bindings. So on top of that, we need to create ergonomic bindings that feel natural for Rust language. So you don't need to do all sorts of weird dynamic casts. You could just use the language as you kind of would expect it would work. And finally, frameworks applications can be built on top of that. So in our current layering, there exist two projects called WebSys and JSSys, which are Rust projects, Rust packages. You can get them from crates. You can add them as a dependency to your Rust project that create those low-level bindings. They're directly generated from the WebIDL definition. And on top of that, what we're introducing today is localGhost, which is very nice bindings built on top of that. And we're gradually building that out. So to give you a concrete example, if we look at a function definition, I picked the worst one from WebSys, which is a keyboard event, initializing a new keyboard event, which takes 12 arguments according to a web spec. So there's a generated version for it. This seems pretty terrible to write. So, we're wrapping it in something that resembles a bit of a nicer API, nice little methods, accessors, that kind of stuff. That just seems a bit more natural to write. Right. So that's it for like the basics and like what are we doing today. Time for some demos, more demos. Yes, great. So let's start making some HTTP requests. So the way you would like make an HTTP request in JavaScript today is using the fetch API. In order to do that, currently you still, if you want to be portable, require a self-invoking async function to have a async context in. It'll go away at some point, but for now. Then probably you want some error handling around it. So you set up a little try catch block in case anything goes wrong. We log it back out to a console instead of like throwing and like the whole thing maybe crashing down. Inside of that, we create a new request, give it a little URL, then we have a request object. Then we send that down to through fetch to actually make the request, and we get back a response. If an error occurs, we catch it. Then we have the response, which means we have the headers, but not yet the body because the body's streaming. So we await that. We say, please give me that as a string. And finally, once we have the full body read into a string, we say log the body, right, with log level info. So in Rust using localghost, we do much the same. In this case, we're importing the log and the net submodules from localghost, so we can log out to the console and we can make network requests. Here we add error handling. I'll get into that in a sec. Then we instantiate a new instance of request. We give it again a URL. Then we send that request away. That's making the fetch request. And we await for that to respond, to return. If it errors out, it goes back up. Then we get back a response. Then we read that response, the streaming body. We stream that into a string. Finally, once all of that's completed, we log it out to the console, right? So the steps are very similar. If you run it, you get this. I just hit literally I wrote that code and I ran it and it completes like that. So there's not too much going on. Just get a UUID from HTTP bin. Yeah. So quick little sidebar, error handling in Rust. How does that work? This is a pretty common one you'll run into pretty quickly. So it's worth paying attention to just for a sec, right? So any function in Rust can return error as long as it defines a result type in its return type. So Rust, you define the signature of the functions. Here you say, hey, this thing can return an error of type IO. It's IO result. You don't need to worry about that too much. The main thing to watch out for is whenever you see a question mark in Rust, it means this is a code where this program or this function may throw an error back up. So if you see a question mark, it just says, oh, that thing can error. Cool, right? Handle the error there. Throw it back up if there is one. And at the end, we say OK again, which goes back with IO results. And it says either, so IO result is a tuple that either returns an error kind or an OK kind. If you've written TypeScript, you might sort of be oh, okay, I kind of get that, right? But we always need to return OK. At some point in the future, Rust may gain try-catch functionality. Try for sure, catch is a bit more up in the air. We'll see. But yeah, anyway, question mark means errors might occur here, in case you're wondering. That's a clear. Also, we bind our .await instead of prefixing it. It's a suffix. Things are the way they are. I like it, but it takes some getting used to. Anyway, next up. So what we've seen so far is on the one end, we've created a DOM node in our little Hello World example. Then we've moved on to make network requests. And now what if we combine the both of them? So, what if we streamed out a bunch of server data and created DOM nodes as server data comes in? So the way to do that, probably the easiest way to do that in JavaScript is using the server-sent event API. So we define a URL here. Then we say new event source, which uses the server-sent event API. We initialize that. We add a little error handler there, which usually either the source is malformed or if the thing actually closes and restarts. So we just add that for good measure. Then we move on to instantiate our DOM. So we want to create a table. And for every element that comes in, we want to append to a table. So we instantiate table element, new row. Inside that row, we create a new text node called name. So a little column called name, a little column called data. And then finally, for every event in our event listener of type data, that's what the data stands for there, we create a new entry into the table, a new row into the table. And we append the name of the data, which in this case is data, and finally the itself, right? And then we append the whole thing onto the table. So every time new data comes in, we add it onto a table, right? Pretty straightforward, 50 lines of code or something. Yeah. So let's do that in Rust as well. All right. Uh-oh, I guess I'm running out of time. The way to do that is instantiate a new URL. Yes, okay, we create an event source. We give it a URL. We define which events we're interested in. In this case, it's data. Then we create the table element. We instantiate the headings, right? It's all pretty much the same as what we've seen before. We append that to the DOM. And then finally, for every event, this is a asynchronous for X and Y kind of loop. We create we insert the data into the table, into a row. And this is what that looks like when we're running it. Yeah. Right. Code's pretty similar is the point I was trying to make. And it actually works. There's a demo you can find on the local. All right. You might be wondering, like, okay, that's cool. We've now seen how we can instantiate Rust in the browser, how we can like use it to make network requests, create DOM elements. But how do we bind this actually to a Rust program or to a JavaScript program? And I unfortunately don't have enough time to probably go into that. There's a good guide on it on Rust WASM GitHub.io. It's pretty straightforward to expose Rust APIs to JavaScript. Just requires some manual work. But there's also a really good talk by Irina Shestak on doing this at RustConf 2019. All right. So in summary, what we've done today is so far we've created DOM nodes, HTTP requests, we've visualized, which means I've shown you like actual practical using Rust in the browser, using all the web APIs, doing a variety of things, which I think, that's not been a common theme before, I think. Anyway, future of Rust and WebAssembly. Oh, I think I'm out of time. Okay.
Hi, Yash. That was a great talk. Thank you very much. I'm going to kick off with some questions, if that's okay. We've got a question from Bran, and Bran asks, what type of app or software will typically benefit from WebAssembly, and what are the obvious low-hanging fruits that we should all be looking for?
That's a great question. Thank you. So what kind of software benefits from WebAssembly? So there, like classically, the example would be like any kind of very heavy algorithmic work, anything that needs very high precision math or like very tight control about like how memory is laid out, how structures are laid out in memory. But what I'm trying to show here today is that we can start to expand beyond that. Assembly is now able to create DOM nodes to make network requests, file system operations, as far as like the browser allows it. So I think it like we'll see a trend as libraries get stabilized towards applications that have a higher level, just have like more stable requirements than, for example, JavaScript may provide. I think there'll be high overlap between what TypeScript, for example, tries to provide and what Rust can provide as well. So if you're building applications that are more in the line of like Photoshop, like heavy, like very intense applications, having like the structure and the rigidity, is that an English word, that Rust can provide maybe actually prove to be very beneficial. Something I didn't quite like cover in my talk is cross-platform SDKs, for example. If you can like access if you can make HTTP requests from Rust, you can use abstractions that like build an SDK that essentially works on Android, iOS, and the browser, but is defined in a single place. I believe Netflix recently showed something similar in Kotlin. I think that will be very interesting going forward.
Okay, thank you. So Ivan asks, what performance-wise, what is the benefit or downside of manipulating the DOM with WebAssembly?
That's a really good question. Thanks for asking. There exists a library in Rust, which is a proof of concept of a virtual DOM implementation called Dodrio. And at the time that was released, which is about a year ago, it showed performance that was on par, if not better, than other comparable virtual DOM implementations. Virtual DOM manipulates the DOM heavily, as you may know. With an upcoming proposal called interface types, actually so currently Rust calls through JavaScript into the browser. With interface types, Rust may call, unlike other languages, WebAssembly may call directly into the browser APIs. So latency will even go further down, which means we'll likely see a future in which accessing browser APIs, accessing the DOM from WebAssembly, Rust, other languages will be on par with JavaScript and possibly even faster. So yeah, hope that answers your question.
So do you think that Rust is going to replace JavaScript in the browser?
That's a pretty common question that's asked. I can't tell the future, but what I'd like to do is help create help bring Rust and WebAssembly to a spot where you're actually able to build full applications with it. And people actually can ask the question like, hey, I'm able to write a full application on the browser, in Rust. Should I do this, right? We're not quite there yet. At this point, we'll see for which teams it makes sense, whether or not Rust is accessible enough, all the other trade-offs. But I want to enable that. I at least want to make it an option. So yeah, it's a fun question. Thanks for asking.
Well, thank you ever so much. I had other questions, especially about localGhost, which is an excellent name, but unfortunately we don't have time to go to those now. So thank you again, Yash. That was incredibly interesting and incredibly informative. Thank you.
Thank you.
So we couldn't run NodeConf Remote without our sponsors. So a big thank you to NearForm, Microsoft, Bloomberg, Red Hat, and IBM. So, and we have a word from our sponsor now, and this time it's from Bloomberg. Thanks very much. We'll see you all again soon.
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull. Bloomberg is
a high-tech,
market-moving, data-driven,
cross-platform
information company.
When we're busy moving the global financial markets,
Bringing transparency to business,
and helping major players change the world,
We go through a lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
well, it's about collaboration.
Across teams?
New ideas can come from anywhere.
It's Bloomberg is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work,
Which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems.
Like
climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局。
In 73 ländern.
世界192カ所にオフィスを持つブルームバーグ。
Și în fiecare birou avem toată lumea.
Diversity is essential for business success.
When we're moving this fast,
It's great to know your employee has your back.
the benefits are excellent.
We take that basic nugget of information
from the financial markets,
And push it out across all our channels.
nanoseconds matter.
Faster, but also smarter than anyone else.
And
We have people answer questions they didn't even know they had.
It's all about smart speed.
we're passionate about connecting
News, analytics,
data,
Seeing every angle.
with the fastest,
real time,
borderless.
Most caffeinated
organization in the world.
Information is everything. I see my ideas come to life.
My work really matters.
Did I mention never dull?
So, hello and welcome back. Unfortunately, as with happens with the live events from time to time, one of our speakers has not been able to make it today. So we're not going to be able to hear live from Amal Hussein. She's not going to be able to join us right now, but she will be recording her talk, The Good, the Bad and the Vulnerable, A Friendly Guide to Dependency Management at Scale. And that will be available on the NodeConf Remote YouTube channel later. So we're very, very lucky that at the very last minute, somebody has stepped in to do a talk. So we have Matteo Collina, the man with 5 billion downloads, and why are there no incentives for security in open source?
Hi everyone, I'm back here. I don't know, it was very unsurprised for me to deliver this talk as well as the previous one at this conference. It was very, very important for me to present a talk about Undici. But it's there was an opportunity, and basically I stepped in to fill in the slots. So as usual, follow me at Matteo Collina on Twitter. Please reach me out if you have any questions or whatever. I have prepared this talk on security and open source, following some of my input from a friend, and I recently delivered it at SneakCon 2020. So here you go. And I'm going to talk a little bit about security. So without no further ado, let's start. I don't see my slides. I know. Yeah, fantastic. I see my slides now. Great. Here we go with the slides. So why there are no incentives for security in open source? So a couple of things about me. Again, I'm as always part of the technical steering committee on Node.js. Didn't change in the last 2 hours. And but as part of that, one of the things that we do, and you might not know this, we are also triaging Node.js core vulnerabilities. So we triage, when we receive vulnerabilities about Node.js, we triage them. And we also fix them, of course. I also research and fix a few HTTP 1.1 denial of service attacks for Node.js. So I know the HTTP 1.1 spec fairly well, probably. Yeah, you probably question me. I will not know what you want, but whatever. I'm also whatever, but I have this dual thing about the community aspect and the consultant aspect. Note that again, I am still planning to reach 5 billion downloads in 2020 with my modules. So yeah. So I know a thing or two about security because it was fast on the previous talk. Now it's secure. You see. I have this nice slide which shows the balance that I need to cater when helping clients and companies and maintaining the ecosystem. Security is such a big part of any runtime and any platform that you're using. And you want to take the security one of your first challenge when developing a new application or developing a new module as well. Note that most people don't care. So, I've recently worked with a client where, this word secure, was not a thing. Okay. And they're working on it very hard to fix, to rectify their problem. But yeah, no, that was a problem. Secure, no. Okay. So a lot of companies do this type of work, and they are in search for protection. There are unspecified attackers that want to access your data or do something nasty to you, your company, because they're jealous and envy, or maybe they just want to make money out of you and do some ransom. So you are in search for protection. The problem is that open source is always pictured as the tragedy of the commons, and let's dig a little bit into it because it's very important. Open source is one. Okay, so if you're developing software, you use open source. This is one of my favorite page, modulescount.com. I always take a snapshot of that and put it in slides most of the time. Note how many modules, how many dependencies are published everywhere between all of those registries. Look, well, this is npm. We all know that we like small modules, but even everybody else is publishing this, is publishing things, and so on. Is actually very important. So all those open source getting published means that all new software it's built on top of all those software companies is built on top of open source. But you might think open source code, but it's not really. It's also a bunch of other things. You need to have product documentation, developer experience, releases, support, licensing, outreach, and so on and so forth, but also security, which is the focus. Note that this specific talk is not about companies. So I am not talking about open source projects that are companies. Those are I'm not going to talk about them right now. There is a lot of open source projects that have a major company behind it that is actually selling it as its own product. We can name a few, which I'm not going to name them. So it's not a startup. Okay, I'm talking about open source projects that are maintained by volunteers that have a full community behind, where the leadership is not tied to one single vendor. And because one of the key parts is that an open source project is as good as its community is. So open source, it's all about community. You need to have a good community to have a good open source project. So go back to our our attackers. No, you see, the company is using open source, right? We have seen that, open source is one, and the company is, the code is public here. Now, the attacker can study the code and use that as an attack vendor. Hooray, they made some money, okay? This is a problem. So there is a big desire for security and to raise a wall around our company's data or our company's system. And as usual, you have two choices, make versus buy. Now, I always recommend to buy. Usually, unless you are building a product to sell, buying it's actually cheaper than building. And you might want to pick as one of our favorite vendors. There are a few of them, and I love them all. So pick the one that you like the most, and that you want to help protect the company. Hooray! So that's nice. And with that, you will be all secure together. Right? Okay, but is it all? Like, are the vendors enough to keep protecting my company? Well, not so. We are missing a very important link. So, in order to provide you very important to provide the company and you developers that develop products for them, you need to you need the open source dependencies, the open source libraries that you're going to use to be without security vulnerabilities. Who's going to fix the vulnerabilities? Well, likely the maintainers, right? So that fix vulnerabilities in the open source. Well, but the important part are the security researchers that are going to notify the maintainers, but study the open source dependencies with the same mindset of an attacker, and then notify the maintainers so that they can fix them. Hooray! Good, right? This is a virtuous cycle, because the result will be that the open source is kept fixed and maintained. Easily realistic. You see, this is like I really like this slide, and this image. So there is the disclosure cycle is actually very important, and it's you can have two disclosure fix. One directly by the security researchers that will communicate to the vendor when if they were unable to get the maintainers to do a fix, or they will talk to the maintainers, work with them, and then the maintainers will do the disclosure of a fix to the vendors. This second cycle is actually very, very important because it actually ensures that the vulnerability is fixed to the best knowledge of the maintainer, which is great. Note that the vendor usually a good job in letting the clients, the companies know and keeping them secure. Okay. Now here is the full-blown security value chain. So let's recap this a little bit. So you have an attacker that wants to access data at a company. How does it do that? Well, it does that by studying open source dependencies, which are that you also use by the company. This is actually very simple to know which library, which open source things you are using. Okay, so whatever. So there is that. The company in turn don't want this attack to happen, so really seek to some help from vendors to keep them their dependency safe. Now the vendors themselves need to know what's vulnerable, so they need to have the disclosure of those vulnerabilities. Who's going to do that? Well, it's going to do the security researcher might do it if something is not being patched, or the maintainers are going to do it if we have a fix. Note that the maintainers fix the vulnerabilities, and after being notified by the researchers, which do the same type of study that the attackers do on the open source dependencies. So you might wonder, where are the incentives? Now, the title of the talk is where are the incentives, right? So let's try to understand who has some incentives. Now, the attackers have really some good incentives to do what they do. They are criminals, right? So they make money. They want to be kings and presidents, and they want to be, big bank accounts full of bitcoins. I don't know. or they have some political agenda. I don't know. Who knows? Okay, they do what they do. Maybe they just do it for fun, but not so much. The security vendors are make money by keeping companies safe. So they have all the incentives to keep it they sell products. So they make money by keeping companies safe. And part of their job is to publish and notify companies about vulnerabilities. And they benefit when open source vulnerability is disclosed. So to some extent, they make money when you have open source vulnerability disclosed. If there are no open source vulnerability disclosed, you will see why I'm paying this company to keep me safe. Okay, so that's it. The security researchers are often employed or sponsored and receive money through bounty programs. We have a couple of very interesting bounty programs, one for Node.js and one for the ecosystem that you might want to use. If you find a vulnerability on Node.js, you can actually receive a bounty. So you can, if you find it, you will receive, there's a bounty on them, and you will receive, I don't know, $250 or $200 or something like that. I don't know, I don't remember. But you can receive some money if you find one, or even more if it's a very, very serious one. So they also benefit when the open source vulnerability are disclosed, because it's they can also reuse that as their CV to land better jobs or make themselves a name in the security community. So again, they have some incentives here. Note that if we go back here, we have talked about the company, which have incentives on its own. Of course, they're selling products, making money. You have the attackers, you have the security researchers. Oh, their maintainers are missing. Maintainers are usually not paid to maintain open source. Ouch! Most of the maintainers are not paid to do what they do. And they take pride in their work, and they love sharing code. They produce content, they produce stuff around. It's actually pretty nice, but to be honest, they're not paid for it. And they want people to use their work, and they like to build new features on their stuff. They are builders. Most of the time, they are builders, not maintainers to some extent. They want to create new idea, pursue new avenues, and maintaining software is very hard and a lot of work. So also because most maintainers, like if you are a company, you want the libraries you're using to be stable and be supported forever. And if you are a maintainer, a creator, you want to create new things. Okay, you don't really like maintaining old things. So unfortunately, maintainers have absolutely no incentives in doing any security work whatsoever. And this is a bad reality. So I just wanted to give a quick recommendation to all security researchers, and if you are into this community, it's actually very important. There is maintainers versus companies. This is a typical big divide, and typically companies care nothing about security. Well, they want to pay some money to make the problem go away, and they focus on making money, and they typically have full-time teams maintaining the products. So they have a product, and they can allocate significant resource to fix them if they want to. Maintainers, on the other hand, are mostly volunteers and focus on keeping the project healthy, and they are interested in keeping their users safe, but they have no time, they have no money, essentially. And that both security researchers and maintainers are on the same side. You want to be there, they want to, they should work hand in hand, and don't see them as antagonists. I have seen some very nasty language from security researchers from time to time of, if you don't do anything, I would go and shame all your work and so on. Don't do that, okay? Especially when you're dealing with a project which is mostly maintained by volunteers. You should, take, how can I help to make this project more secure? Not, you should do this, and that, otherwise I will shame you publicly, essentially. Note that this applies only to open source project. If you're talking to a vendor and the open source product that you are using, that you are targeting, is actually built by a company, sure, high ham to a higher bar. They have plenty of resources. Otherwise, please, everybody, let's work together in fixing those vulnerabilities. I would also like to thank the community of researchers to keep everybody safe. And I will just say a big thank you to everybody. I kind of rushed it through. So I hope that Katie has some questions for me that we can go and keep talking about things. So here we go. Anyway, if you are willing to, if you need some help in your Node.js, if you need some help with your Node.js, please reach out. I am Matteo Collina. You can reach me at Matteo Collina on Twitter. And this is my email, matteo.collina@nearform.com. So please reach out if you need any help with your JavaScript strategy and how you want to improve your JavaScript deployment, pipeline security, and so on and so forth. We can help you do all of that. And we've done all of that so many times for our own clients. Thank you. Hey, Katie, sorry, I did rush through my talk. So as you can see, I did not prepare this. So I was a little bit in a hurry to put it I basically jumped it and jumped it on stage. So hopefully everybody liked it. I don't know. I don't have a slide open, so maybe you can. You know the feeling on the room.
I've got a few questions. Well, I've got a question for you here already from Natgur, I think. I think that's how to pronounce it. What if maintainers got paid for consulting for vendors and vendors are delivering fixes to companies whilst contributing to OSS?
So a couple of things. It's not easy for all all maintainers to receive money because of contract obligations because of their employer. In certain countries like the US, you might not be able to receive money outside of your main employment contract. Then you can have problems for receiving money from abroad or whatever. Again, you might not be set up to be essentially a freelancer. If you want to accept money and be okay with your taxes, you actually need to be set up as a freelancer in your company, in your country. So all of that might not be worthwhile, and it requires a significant harder. It's a bigger problem than your normal day-to-day activity, essentially, as a developer. Now, apart from that, so that's one reason. Of course, companies should put money into doing their work. Okay, so companies should definitely put their money into developing the fixes if they can find them. So that's important, super important. So let's do that. Okay, if you find that vulnerability, if one of your developer, security researcher, or whatever find a vulnerability, please let them help in fixing that. Most of the time, people don't. Most of the bugs that we find don't have a patch. They don't even have a hint on how that could be fixed. So it's actually very hard. So please help. We need you.
So what would be the first steps to helping them? What would be sort of your ideal path, and how would you grow this community of maintainers?
So from my point of view, you're missing one of the things that's missing is the need for a need of shared ownership project and shared ownership of what it takes to ship them. If you're using some open source and you find a bug, you should enable your developers, your teams to contribute back. You are receiving a lot from that, and if you find a bug, it's on you to fix it, essentially. And this is kind of the main that will lead to a better community for us all and better software for us all.
Yeah, I think that traditionally it has been so easy for companies to go, oh, I'm using that, but I'll fork it at that point rather than contribute a fix back. I will fork and put my own patches in, and it happens. And it's about making people aware that it isn't a high barrier to entry to contribute things back. It's not a difficult process. It's just something you have to put a bit of effort into. And I think that that's the part of the trouble, is not everybody Not everybody engages in the right way.
No, not really, unfortunately.
Yeah.
So,
I am looking to see if there are
is there
any more
anyone else?
questions. Does anybody else have a
Okay.
question? Do you want to put them up on Slido? Yeah. Well, if nobody else has got any more questions, and I'm going to give you another second as I start just talking about what we're going to be doing next. So, up next, we have the virtual booth crawl. So if we were physically together, this would be the point where you'd go out and grab as many stickers as you could from the vendors. But we don't have physical stickers, but we have other incentives to go and see people. So below the video box, there is a number of links to the virtual booths. If you click on those, you can go into them. There are games. There are an opportunity to talk to the speakers that we've had on today, and also to other people from our sponsors. What up next? We have, after the break, Trevor Norris, Vlad de Turckheim, and Liz Parody are coming up later. And just a reminder, please put your questions, if you've got any, into Slido. I look forward to seeing you back after the virtual booth crawl. Hello, just to let you know, the links for the virtual booths are now available. If you look in the chat window on Slido, you will be able to see the meetings, the Zoom meetings, which you can join for the virtual booth crawl. All right, cheers. Thanks. Hello and welcome back. I hope you enjoyed your virtual booth crawl, and now we're back with Trevor Norris. So Trevor works at NodeSource doing research and development on different metrics and insights that can be gained from the event loop and how to utilize it to improve monitoring and scaling that use Docker threads. He's been a Node.js developer for over 8 years, and 5 of those he's been a member of the Node Technical Steering Committee. So please welcome Trevor Norris with the introduction to event loop utilization.
So, thank you everyone for being here. Glad I can be able to give this talk about all the research I've been doing over the last year pertaining to event loop utilization and about event loops in general. So to start off, we're going to talk about Node's event loop. This diagram you see is the event loop that appears on the Node.js official documentation. It has all the different phases that you see. But the problem is that this event loop isn't simplified enough. It isn't close enough to the conceptual event loop. There are a lot of implementation details to be concerned about that make things too complicated when you're trying to reason about how the event loop works. So to simplify it, we can look at the event loop as having only 2 phases. The first one is the event provider, and the second one is the event dispatcher. And there's just a couple simple operations it goes through. So first, events are received from the event queue, such as the kernel, through the event provider, like epoll wait. Now, if an event is waiting on the event queue, when the event provider is called, it is immediately returned. If no event is waiting, then the event provider will block or idle until an event arrives. Now, when the events arrive, they are dispatched. Now, this is different than calling the callback. The event handler is the calling of the callback. But since libev can do more than just calling the callback, such as stop listening to the file descriptor, that step is called the dispatcher. Now we're going to go on to a timeline of an example execution of a few event loops. So the top line is the event handler. The second line is the event queue. Now in loop 1, the event provider is called. No event is waiting in the event queue, so it idles. Once event 1 arrives, it's immediately passed back up and processed. While that duration of time before event 1 arrived is what we'll call idle time. Now, while event 1 is being processed, events 2 and 3 arrive. Then, once event 1 is done processing, loop 2 starts. Events 2 and 3 are immediately returned and processed, and likewise, when they are being processed, event 4 is placed on the event queue and then returned and processed. One thing you should take notice of in this diagram is that the event loop starts at the poll phase, unlike with Node's event loop here, where poll sits in the middle. Again, because of implementation details, such as needing to run timers and possibly only quickly running, possibly skipping over poll to do certain things, the proper conceptual event loop runs poll first. So why does this matter? Because it's easier to reason about what happened in a loop once it's simplified. And when I was doing my research, I first started by adding metrics, counters, and timers to every facet of the event loop I could, every phase of the event loop. And in the end, I was tracking about 30 metrics, and very quickly it became apparent that I wouldn't be able to make sense of all the data. It was impossible to make correlations with all of that data because there was just too much of it. So over time, I stripped down and eventually came down to a very small subset of metrics. And I realized that using that small subset of metrics, I was able to get information about the event loop without losing any accuracy. And by doing that, I was able to extrapolate using the simpler information into more of what could be used for metrics and monitoring. Now, this works because we can think of all work being done in the event loop as work that needs to be done because an event fired. Yes, you have timers and it can do miscellaneous work, but it's just helpful to think of timers and think of all work as work done as an extension of an event. So first, the idle time. That's the most basic event loop metric, and calculating idle time conceptually is simple. You just say it's the amount of time blocked or idle within the event provider. Unfortunately, it's not that easy to calculate. We'll get to that in a little bit. Actually, right now. So one of the idle time implementation notes is that now the event provider APIs such as poll, KQ, and all the others, they don't have any option of returning if there were any events waiting in the event queue when it was called. So in order to accommodate calculating idle time correctly, I patched libuv to first make all the first times it calls the event provider, it always does so with a timeout of 0. Once it does that, it will immediately return whether an event is available or not. If an event arrived, when it immediately returns, the event is processed and execution continues normally. If there are no events, it will call the event provider a second time immediately after, except that time, it will measure that call into the event provider as idle time. Unfortunately, any performance overhead of needing to make 2 calls disappears once the load increases, because then events will usually be waiting. So it's not something you need to worry about having any performance overhead. Now, on to what is event loop utilization. Well, simply defined, it is a percentage of time the event loop is not idle. And unlike CPU, the event loop utilization, or ELU, can never be greater than 100%. And the ELU can be used to our advantage in 2 ways specifically. First off, we'll find, as we'll see, it's a more precise way of measuring the process's capacity. And the ELU can be used to get information from each worker thread. There is not a cross-platform compatible way of retrieving thread-based CPU usage, but ELU can be calculated for every event loop running on every thread, helping us monitor all the workers. Now, event loop utilization has landed in both perfhooks and worker threads, and we'll get into those in the example usage. Now, first, we're going to look at some graphs of CPU versus ELU to get better understanding what's going on. We'll just jump right into the graphs, and on the left here, you'll see request per period. On the right, you'll see the percentage of ELU and CPU. And on the bottom is the number of connections as they increase. So these 2 graphs are simple example servers using, as you can see, most of the amount of time spent in the process is spent in the main thread running on the script. These are the 2 these are the 2 simplest examples of how it works, where they trend closely. Now, as you'll also see, the servers have different scaling curves. One tapers off gradually, the other one is very linear until it hits full capacity. We'll get into that a little bit later on. Now, here on the right, we have one that's generating a lot of garbage, it's generating a lot of objects requiring the garbage collector off the main thread to collect that. As we can see here, that the CPU can be substantially higher than the ELU, but the requests don't reach maximum capacity until the ELU reaches maximum, or 100%. The bottom, likewise, it's where the crypto library is doing off-thread work, and it has about the same look and results as the garbage collector. Now here we have a worker thread example where we can see in the top left, we're using worker threads to process requests by doing templates. And while the requests do taper out, we'll see that the ELU doesn't. In the bottom right of that first graph, we'll see it's about 70%. And we can use that with you as a way to roughly calculate the number of worker resources that need to be dedicated in order for that process to reach maximum capacity. So it was done again using that estimate in the bottom right, and as you can see, the number of requests increased about by 100 per period. Now, real quick, the request per period is different than request per second. The request per period is the number of requests that can be done within the collection period. It's a correction mechanism that I found gives you better statistical data when doing cross-process comparison of what's happening. Here are two interesting examples. The first one is the same worker thread script, except that it's running within a container, and I only allowed it to use one CPU worth of resources. But as we can see, it hits the CPU max very quickly, and so does the request per period. But then the ELU is very slowly, but almost indistinguishably ramping up. And that's because what's happening is it's kernel swapping other stuff. But we can use, if we look at our total CPU usage along with ELU, we'll be able to notice that the limiting factor here is in fact the hardware and not the software. So CPU, while in terms of monitoring isn't as useful as ELU, it is still useful to use in correlation with each other to find other situations like this. And likewise, at the bottom, in this scenario, the file system is writing synchronously to a network drive, and as you can see, CPU is actually substantially lower than the ELU, meaning a lot of time is blocked and a lot of time is idle, but since it blocks the event loop from proceeding to process other events, it is considered not idle time. So we're going to get into a few example usage scenarios. This first one is a simple case of just using the three basic forms of the API. First one is you're getting the amount of the ELU from the beginning of the thread, also from between 2 points in time. That's very similar to HR time. And then the last one is just a little addition so that you don't have to do the math on your own of just subtracting the 2 times to get the difference between 2 points in time. And here's a very simple example of using it to record the ELU in an external collector of some sort. Basically, you need to get first time and then you update it. It's very similar to getting CPU usage in this case. So here is an example of how to use ELU as like a first check to see if how your process is doing within the HTTP server. What we care most about when we're serving requests is our ability to serve them quickly. And if idle time ever increases, then we know that the event loop has had a chance to breathe, that whatever request that is being received did not have to wait in the event queue. And so what we're doing is we're measuring the ELU in each request, and we're taking the difference between the 2 times. Now, if you look down at the if statement, you'll see that if idle is equal to 0, meaning the event loop might have been able to turn and iterate, but it didn't ever have a chance to idle, meaning it didn't have any chance to breathe, and events were always waiting in the event queue to be processed at some point. And then the active time is the amount of time, the active time is the amount of time it has been running in total. So if active time is over the threshold and it hasn't been idle, you can use this as a first step to make sure that your server is running okay. If this never fires, then you honestly don't need to worry about anything else. Even if CPU gets pretty high, as long as the event loop has time to breathe, that means it has time to process requests. Now, this example demonstrates how to use a message channel between two worker threads, or sorry, a worker thread and the parent thread, to send the ELU from the worker thread to the parent thread. And it's a total mess. So to get around that, I added this API recently to the worker API, where you can directly retrieve the ELU of a worker thread from the worker itself. Now, this is a thread-safe call, and it's immediate, so you can retrieve the ELU from the worker whenever you want, and you can retrieve it whether the worker thread is busy or not. So you can monitor your worker regardless of the worker state. All right, another area we can use ELU is an anomaly detection. Since ELU is a more reliable way and a more consistent way to measure the metrics and the state of the application, it can be used to see, we can use it by comparing several different processes together at the same time. As you can see on this chart on the right, we see on the x-axis is the ELU, on the y-axis is the CPU, and there's a fairly solid trend line between most processes, but then there are two that lay outside of the norm. Now, this can be used manually or automatically to connect CPU profiles or heap snapshots to let us know the differences between a normal process and an anomalous process. Now, last thing we're going to get into is an idea I have of scaling by responsiveness. ELU gives us an ability to do more with checking the state of our applications. Now that we have a better way to compare applications and processes, we can group them and trend them. So what is the idea? What's the purpose of scaling? Well, the purpose of scaling is to allow us to give users a good experience. If we wanted to save money, we would go ahead and not scale our applications and users would just have to wait for a response. We don't want that. So then why is it that we don't scale by responsiveness of the application instead of by CPU usage? CPU usage is just sort of an arbitrary value, like CPU of 80%. We're just hoping that around 80% things will get bad enough that we have to scale. But we're now able to do something better. Here are two graphs that are comparing the latency per request, and in the red is the events per loop. The x-axis again is ELU. So it's doing a comparison of multiple processes together, and as we'd expect, as the amount of work increases, the trend of the number of events and the amount of latency per request increases as well. And using this, you could create a model of when exactly you should be scaling your application. If you wanted linear, if you wanted linear latency and a solid experience, on the first graph you could wait until 70%, but on the second graph you could go till almost 80% before any users would notice any difference in the user's experience. Now, the advantage of this is that you have better control over the user's experience, but also you're able to more closely you're able to save on resources, because if you always arbitrarily chose a specific CPU amount, then you don't know whether you're wasting, if you're allocating too many processes and paying money in a server that you wouldn't need to. And the advantage of using ELU also in this case is that it has pretty much zero overhead. To measure the overhead, you're measuring CPU instructions. Now, this one is another example HTTP server that I ran, and as you can see, it's almost linear all the way up to 100%. And this is a good example of knowing when to scale and knowing how to scale that can save you money in terms of server costs. You can not scale until 90%, and users won't really notice a difference. And the bottom one, the sporadicness, you can see a good indication of the worker thread capacity. The overall trend line is fairly flat all the way up to 100% ELU, but response times then begin to scatter after a certain amount, because just the way that the hardware or the kernel allocates time for each worker thread and CPU dedicated resources. And this is fairly normal, but at least this way you can still get a solid trend line of how things are going. This one is especially interesting excuse me. This one is especially interesting because of this weird curve that it has. Now, when this happened, it was, I didn't believe these values in this graph when I first saw it, so I spent hours redoing it, retesting it, measuring it from different angles. But in fact, this gain curve looked like for this HTTP server, where it's linear right up until it hits a point. And from what I gathered, V8 was having a hard time processing what was happening. So it spiked really fast. But then as you see, CPU, as the amount of usage increased, suddenly V8 could process things better and latency per request decreased up until it reached maximum capacity. So the takeaway from this is that by improving our understanding of the event loop, as we have done, and implementation in the ELU, we're able to make more consistent metric. We're able to take those metrics and make more consistent cross-platform comparison or cross-process comparisons, use that data to be able to help us create the trend lines and understand our application better so that we can scale more intelligently. And the other thing is that, as we saw, for example, in this case, that when you're doing load balancing of your servers, you should absolutely measure the scale of the entire breadth of utilization, because you might run into these anomalous times, these anomalous things, and you can measure those and know those and then go back and reevaluate if you need to change something or determine exactly when you should be scaling, because during your load testing, you could create an example trend of how you believe that the process should run, and comparisons of that along with what the processes are actually showing as they do run, to see if your model of how you think your application is going to run actually works. I think that's about it for my presentation. Thank you very much.
Okay, thank you very much, Trevor. That was incredible. The idea of having I've worked in projects where our main scalability metric for increasing the number of boxes we have going is the CPU. So something which is a much more, what you're describing is a much more robust and extensible measure of it, which is it's a lot it's a lot better than CPU, which is quite a random-ish thing, I think is what you're trying to say.
Yeah.
How easy would it be to start using this in production? Is it something that's available now, or is that it time to get into production?
No, well, in terms of usage, it's landed. It's now available in version 12 and up, so you can begin using retrieving event loop utilization via the Perfux API starting in version 12. And it honestly, in a way, can just be a replacement for CPU. So if your baseline is just to scale at a certain percentage, you can swap ELU out for CPU and scale that in.
So it should be relatively straightforward, provided you're using the version 12. Cool.
Yep.
I'm just going to check to see if the channel's got any questions for you. Just to remind people, you can ask questions on Slido, which is either through the Q&A tab or through the chat tab. I don't think there's anything else coming through. No, I'm not seeing any additional questions, but if anybody needed to get hold of you after thinking about this, so you are available on Twitter, aren't you?
Yeah, yes, I am. Twitter, and then also IRC in the Node channel. If anybody wants to hop in, send me a message in some way. I'll be happy to help you out and give you more information on how to use it or usage examples. The ones I gave today are fairly simple, since ELU can be used similarly to CPU. Like I said, you can use it. You can use it almost the exact same way that way. Also, the documentation, I made sure to include examples and a couple of pitfalls of what you may or may not expect, so you can reference those as well. The tests are really comprehensive in terms of what they measure. So if you feel so inclined, you can also look at the tests.
Oh, brilliant. Thank you ever so much, Trevor. That's really, really helpful. So next up, we have a word from our sponsors, Red Hat. And following that, we've got Vlad de Turckheim, who will be talking about async local storage usage and best practices. So our sponsor, and then we'll be back with Vlad just after that. Thank you. Hello, welcome back, and we're about to talk to Vlad de Turckheim. So, based in France, we've got Vlad, who has a very secure history and has worked as a professional security auditor, and he gives talks and training to software engineers to teach them about application security. He now works at Screen, which I hope I've said correctly, where he builds secure web applications. He's one of the most active members of the Node.js Security Working Group, where he handles the security of Node.js and its ecosystem. So today he's going to be talking about a curious API that was added to Node this year. I give you Vlad de Turckheim and AsyncLocalStorage usage and best practices.
Hi. Thanks so much for having me. Let's go. So, can you see my slides yet? Awesome. So thank you and welcome to my talk about async local storage in Node.js. Quickly, but I've been introduced. I'm Vladimir de Turckheim. I'm the lead customer engineer at Screen. We secure web applications. So if you've got Node.js in production, you probably want to check what we do. Also, for those who know me, I'm usually wearing a beard. And because this year I'm taking part in Movember and trying to raise money to raise awareness regarding masculine health and mental health, I decided to shave and grow a mustache this month. And if you want to support me for Movember, please click on my link and donate for that. I would actually really appreciate that. Thanks so much. Let's talk about thread context. And most people are about to ask threads. It was supposed to be a Node.js talk, but we will still talk a bit about that. So let's take some code. It will be a presentation that will be heavy on code. Here we've got a log function defined from line 1 to 3. And as you can see, the first argument taken by this log function is a request object, an HTTP request object. And on line 2, when we log something, we do console.log rec.id, and then we log the rest of the arguments. This function is made to be called in a middleware, so every example in this code are made with Express. I love other frameworks, but that's what I had ready. And we create a middleware that takes request, response, and next as parameters. And each time we want to call the logging function, we need to pass the request object as first parameter. And yes, we need to pass it, and we got used to pass rec enclosures or as argument everywhere in our code. Like that for decade, at least one, with Node.js. And as a Node.js engineer, we all got used to doing that. Of course, someone could argue, hey, you could only pass part of it. So let's say I just want to pass the ID to my log function. I would make my log function take a first argument as an ID and then log. But then maybe you want to log other traits of the request later in the life cycle of your app. Let's say you want to also log the method. And then you have to update the signature of the function and the signatures of all functions calling it. So it quickly becomes a mess. And that's an easy case because there is only one layer of call. So in my example, we've got the controller, the Express middleware, calling the log function. But what if you are calling methods through other abstraction layers, like if you have services or data abstraction layers? You need to pass something about the current HTTP request all the way down to the last line of code in the layers of your application. And that's a mess. And why do we have to do that? Do we really have to do that? And how do they do that in other languages, in other technologies that are not Node.js? Well, in a threaded world, like in PHP, in Java, in Ruby and Go, most of the time, what they do is they create a new thread for new incoming HTTP request. And a thread store. where they can store something that is linked to this thread, and that's a singleton in this thread. So for instance, in a Java Spring application, if you don't go with asynchronous methods, at any time you can just say, hey, I'm in a thread, what is my current HTTP request? They can do error handling, and they can do context keeping, and that's basically a big bind function that is bound to the thread. In a single threaded world, there are multiple HTTP requests handled in the same thread, and there is no single truth. It's actually really hard to say this line is executing because of this HTTP request. And I will demonstrate that with an example about exception handling. I've always considered that exception handling in Node.js was weird, and at one point I just accepted it and decided that it was cool, but it's still weird if you take a step back. So we've got two examples of code here on this slide. On the left-hand side, we've got an async function named main that awaits a promise that just resolve and then throw a new error. And then we code it with a rightful catch. And if the error is caught, we can just log down because a successfully caught promise failure returns promise fulfilled. And on the right-hand side, we've got pretty much the same thing. With one exception, there is a process.next tick around the error being thrown. But the way we call main is the same. If I run the first piece of code, I actually get exception logged, my exception, and then it logs down because the line 9 of the code on the left-hand side is executed successfully. On the other hand, if I run the code on the right-hand side, well, I just get an exception and the process crashes and the console.log down, the line 11 is not executed. And that's what I mean when I say error handling in Node.js is weird, because depending on how you call things, whether you are in an asynchronous operation, in an async call, in a promise chain, you have different outcomes. And one of them is the process crashes. So the next tick asynchronous operation lost a cause stack. And Node was not able to know why it was running this line of code because the cause stack was lost at the asynchronous operation. So that leads me to the second part of the talk. Why is this piece of code executing? When you look at a line of code in Node.js running, why is it running? So that's why we created async local storages in Node.js. It's an API you can use to create context in asynchronous environments. So async local storage is used to create an asynchronous proof store. Basically, it creates a context for your code and will spread it through the event loop for you. Okay, so it's a pretty straightforward API to use because you just request from async hook core module, and then you call new on it. So that's what I do on line 3. I call new async local storage and I create a context, and I need to create only one. And then I need to enter the context. I need to start running code within the scope of the context. So that's what I do on line 5. I call context.run. The first argument I pass is what we call the store. It's actually the value that will be available for all calls made within the context. Then I pass a callback function, and everything there will have access to the map that is created when we call context.run. Don't worry, there will be better examples right after, like in this slide. So remember the examples about my logger that gets extremely verbose with a terrible signature? Well, let's fix that. So on line 1, I require async local storage. On line 2, I create a new context. And then I create a log function. And this function only takes arguments to log. And what it does on line 4 is it retrieves the current store. It calls context.getStore. So this might actually return undefined if you're not within a context. So my code is terrible at error handling here, which is a bit ironic, but I wouldn't have enough room on the slide to do things as I wanted them to do. So please don't blame me too much on Twitter. On line 5, we get the request from the store. In work, the store is just an instance of map. And then we can log rec.id and the rest of the parameters. On line 9 to 15, we have a first middleware. What it does is it creates a store, which is just a new map, and you can use any other value actually. And then, as explained in the previous slide, we call context.run with the store. And what's important is we set request inside the store, and we call next in the callback. And from now on, everything that happens called after this single next call on line 13 will have access to the store, meaning that context.getStore will return the map we created and we pushed the request inside. And now on line 19, we can just call log, and it will log the things properly as it was bound to the HTTP request. So no more need to move request around, right? You can always know what is the current request context, which is actually pretty cool because you can make your code less verbose. But logging is just an example. And let's talk again about exception handling. In my case, I've got a first piece of code, first middleware that calls /async and throw an exception in process.nextTick. Then we've got a second middleware /sync that throws an error directly, and then we registered an error middleware to tell Express what to do with our errors. So let's run this code. If I get on /sync, it actually calls the error middleware. If I call /async, it crashes the process. Once again, it's a question of stack trace. So actually, Express injects a hidden try-catch around all middlewares. And the reason why in the first case it called the error middleware, because there is a try-catch around the callback you pass to the middleware, around the middleware function. It's caught and spread to next. But in the second case, Node is not able to know that the try-catch, the implicit try-catch Express put on line 1 is related to the error thrown on line 3 because of the asynchronous operation on line 2. So let's create a handling error mechanism. So at the first line, I create a function named handle error that takes an error, request, and response as parameters, and it does whatever we want it to do. That's not really important for this demo. But on line 5, from line 5 to 10, I will do something that the Node.js documentation explicitly discourage. But I think it's time with this API we rethink this discouragement. So I'm supposed to use on-unquote exception on the process level because your application might be in a weird state, an undefined state. However, thanks to AsyncLocalStorage, you have a way to keep a real state for your application and know what is happening. So in my case, register a handler for unquote exception, get the request, the response, and spread it to handle error. Once again, this could return undefined and there might be mistakes in my code, but that's for the idea. And then I just tell Express on line 12 to use an error middleware that's forward to my handle error function. If I call /sync in the previous code, it calls handle error through the error middleware. If I call async, it calls handle error through the unquote exception middleware. That's for the unquote exception event listener. And we have a unified way of handling errors in Node.js under certain circumstances in this situation. Other use cases, well, someone told me about user management, like when a user is identified into the app, they will just set it, and now they don't need to pass the user to the database layer in their code. They can just fetch it from a store and log the operation in the database to that user directly. Monitoring, you can build your own monitoring tool to automatically track, log, and monitor what happens in your app. Having a single database transaction for the HTTP request you just retrieve to your store. If you have other ideas, let me know. Okay, and since I still have 10 solid minutes before the end of the talk, let's spend 5 minutes on seeing how the code looks like for this API in Node.js. So believe it or not, this API is only 72 lines of code or something like that. Okay, yeah, I know. It relies on a lot of internals of Node.js, but actually the AsyncLocalStorage class and its companion AsyncHook is very light. Let's track how it works. So here I've got a simple example. I create an instance of AsyncLocalStorage on line 4. I call another method, another way to get into the scope of a storage. That's a synchronous way. That's a way that won't require a callback. That's enter with. I just set the store. And now I start foo bar into my map. That is my store. And if I call process.nextTick, I can log session.getStore.get foo, and it will return bar. In Node.js, everything happens in the context of an asynchronous resources. So there are resources, and at each time you are within the context of one. So in this example, almost all the code happens in the resource of the first scope, of the parent scope that is created by Node.js, the core one. But the line 10 is executing in the resource related to process.nextTick. Okay, that's weirdly theoretical, so let's go with a real example. Hopefully there is a great API in Node.js that has been built by amazing people. That's execution async resource. And for each of these resources, we can actually get an object that will represent the resource. So on line 4, we console.log the current execution async resource. On line 7, within a nextTick, we do the same. We got a log. The first object is an empty object, and the second one is an object that has been actually linked to the process.nextTick. So each time we've got an asynchronous operation, whether it's a promise, whether it's another kind of asynchronous operation, we've got a resource object created and accessible at any time. So what's next? Let's take our example and go through the code. We've got a new AsyncLocalStorage. Well, it's a dummy constructor. It creates a symbol. We'll use that later, and sets it to not being enabled. Okay. Then we call session.enterWith new map. This function is a bit more complex. What it does is, if we are not enabled, it enables the thing, and it pushes the current instance to something named storage list. Let's see later what this is. So it calls storagehook.enable. So storage hook, it's an async hook with just an init hook. So each time there is an asynchronous operation created, this will be called with the parent and the child resource. Okay, so now we set something in the store. We just call getStore. GetStore, it's pretty easy. We call execution async resource, and we ask for the store that is linked to the current resource. Okay, now we call nextTick. As I told you, it means that our init function will be called. So it only uses an init hook, no before, no after, no delete. So what it does is it actually finds the parent resource, which is the current one when you create something, and spread the data to the new resource. That's the propagate method. And the propagate method just takes the store from a resource and spread it to another one. And that's as simple as that. And then when we get into our nextTick, well, we are in the new resource, and we call getStore again. And getStore, it just gets the current resource and gets the value of the store attached to this current resource for this instance of AsyncHook. So you can check the source in Node.js core. It's in /lib/asynchhooks.js, and it's pretty straightforward and easy to understand. It's memory safe and pretty fast. I have to highlight that there is currently an API, a PR on Node Core that fixes a memory leak in one of the functions that I have not disclosed in this talk yet. So Brian, don't send me messages immediately to complain. A few best practices and gotchas. That's the last part. This is prod ready. as it is still marked as experimental in Node, but there is an ongoing thread about marking it as experimental. It's coming, it's usable, it's already used in production. And there are actually discussions. There is a stage 0 proposal to bring a similar API directly to ECMAScript. Be careful, there might be things that break it. For instance, if you build queues, you don't have this change of asynchronous resource. Because let's say I just have an array and I push things at the end of the array and I pop things from the beginning of it. I have a queue, and it won't be really possible for Node to really know what you pushed in its context, what you got in each context, if you wrote your own queue yourself. So there is a very handy API in Node.js core named async resource. It's also in async hooks core module. And what you do is that you can register your own async operation that will actually trigger the call to init each time you are going through that. So please take a look at this API if you have custom things that might break this context when you've got improper asynchronous context. Don't share your instance of AsyncLocalStorage. So if you build a module that uses AsyncLocalStorage under the hood, don't share it outside. You don't want anyone to pollute it, for instance, and you don't want to share the namespace globally. For instance, there is an original module doing that's named Continuation Local Storage, and there has been a fork of that named CLS Hooked, and I'm so mad that the CLS Hooked actually breaks the use of the continuation local storage because they overwrite things on the same places on process. So don't share your instances. The fact that the instances are not globally shared is by design. Don't share them. Okay, best practice might go against the previous one. Don't create too many async local storages within one app. So my rule of thumb is create one per scope. Create one for your business logic, have one for your monitoring tool, and have one maybe for security layer, especially if you use Screen. But don't create too many of them, because each time there is a new asynchronous operation, each time init is called, we have to loop over the instances of async local storage. Consider the store as immutable if you're using basic types. So if you just put a number, a string, consider the store as immutable and keep the state keep it the same. And for anything else, I know it's discutable. Use a map, and everyone will expect a map, and nobody will have weird optimization path in V8. Use a map for everything else, and don't step on each other's toe by writing on the same entries as your coworkers. Use the run method to get into an async local storage. You know, it's the one that takes a callback, and use enter with only if you need to. So if you're interested in going in depth about the issue raised by callbackless entering, you can check the domain postmortem on nodejs.org. It can lead to weird behaviors that are predictable but needs a really good understanding of what's happening under the hood. So the run one actually scopes the thing and in the callback, so use that. There's another method called exit. If you're not sure that your context will be garbage collected, that there are too many asynchronous tail calls at the end of a request, for instance, use exit to positively leave the store. And last but not least, go for it and provide feedback, please. We are waiting for that. We love feedback. We want it. Thanks so much for your attention. Let's keep in touch. You can email me. You can tweet me. Here is my Movember link again. I will post the slides on Twitter in a couple minutes. So stay tuned. Enjoy the rest of the conference. And thanks so much for your attention. Sorry, Katie, I don't think I can hear you.
Hi, my name is Joe Seppi, and I am an open source engineer and advocate at IBM. IBM has never avoided taking on big challenges. At IBM, we are privileged to drive impact at scale. We take on challenges that transform our clients, impact people's lives, and innovate for future generations as we strive to affect systemic societal change. Over the course of our 109-year history, the evidence has become clear that scaled change is best achieved through the focused deployment of technology, and especially tech for good. Call for Code, a program created by David Clark Cause and supported by founding partner IBM and charitable partner the United Nations Human Rights Entity, invites developers and problem solvers to build solutions that take on societal issues. Together with the Linux Foundation, we support the deployment of open source solutions around the world. Call for Code has a proven record of successful global programs that for 3 years have been addressing some of the most pressing challenges of our time, including COVID-19, climate change, and natural disasters. Call for Code has grown to include an impressive ecosystem of technology and humanitarian experts and more than 400,000 developers across 179 nations. I'm going to turn it over to my colleague now to share with you a new Call for Code initiative.
As this program has illustrated, when we combine technology and talent, we have the power to drive meaningful change. And as 2020 has reminded us time and time again, our world needs change. Our survival requires. I have the great fortune of leading the hybrid cloud and edge ecosystems at IBM. I also have a great responsibility as a leader within IBM's Black community, a community that sprang into action following the murders of George Floyd, Ahmaud Arbery, Breonna Taylor, and too many others, to demand and enact change. Call for Code inspired IBMers of all races and backgrounds and job functions to think about the role technology could play in driving progress towards a more inclusive, equal, and just world. We recognize technology alone cannot fix hundreds of years of racial injustice and inequality, but when you put it in the hands of the Black community and their allies, technology can begin to bridge the gap. The outcome has been nothing short of astounding. The outcome has given me hope. The outcome is a collection of open source solutions developers and problem solvers across IBM and Red Hat have created in less than 3 months. Solutions born out of a need to turn this critical moment in our history into a sustaining movement. IBM provides the tech, but in keeping with the principles of Call for Code, it takes an ecosystem to scale change. With that, I am honored to announce Call for Code for Racial Justice. Call for Code for Racial Justice encourages the adoption, incubation, and evolution of open source projects to drive progress in 3 key areas. First, police and judicial reform and accountability. 2, diverse representation. And 3, policy and legislation reform. We will be launching starter kits for the initial technology solutions and will be releasing additional solutions over time. Your role, to the developers first, you have the skill set and the ingenuity to make a difference. Contribute to or use our open source projects once they're available. To the organizations and enterprises, you have the responsibility to make a difference. To your employees and to the world. We hope you will commit to the cause to leverage technology to drive progress in combating systemic racism. And from IBM, you have our commitment to continue to listen, learn, and use technology ethically and responsibly.
Hello and welcome back. Next up, we've got Liz Parody. Liz is a community taught software engineer focused on JavaScript and the head of developer relations at NodeSource, where, amongst other things, she is the interface with the general open source community for general planning and evolution of the Node.js open source project. She's the organizer of JSConf Colombia and a huge supporter of women in tech, and also organizes the biggest meetup for women in tech in Colombia, Pioneras Developers, as well as being the organizer of the first Startup Weekend Women's Edition. She loves sharing knowledge, promoting JavaScript and Node.js ecosystem, and participating in key tech events and conferences to enhance her knowledge and network. Please welcome Liz Parody, who will be examining observability in Node.js. Hello, Liz.
Hello all. Hi, thank you. I'm very happy to be here. Today, I will be talking about examining observability in Node.js. My name, as mentioned before, I'm Liz Parody, and I'm head of developers relations at NodeSource, and I am from the beautiful country of Colombia. So this is the agenda for today. First, we're going to talk about what is observability, then why observability is important, how we can use Node.js internals for observability, including performance hook, trace events, heap snapshot, V8 native module, and then we will look at some external tools for observability, benchmarks, and conclusions at the end. So let's begin by understanding what observability is and why it is important. Observability is a term from control theory. According to Korea, is a measure of how well internal states of a system can be inferred by the knowledge of its external outputs. In other words, we can see the results or the outputs, and then we can know what's happening on the inside. Let's take, for example, bananas and avocados. In Colombia, we have a lot of bananas and avocados, and just by looking at the outside, we can know how it's on the inside, if they're ripped or if they're not ready for consumption yet. In software products and services, observability means that you can answer any questions about what's happening on the inside of a system by observing or by asking questions from the outside of a system without needing to ship new code or to answer questions. And that's very important because we shouldn't need to write new code to observe what's happening inside of our system. System complexity is outpassing our ability to predict what's going to break. There are super useful tools that come to the rescue. And talking about system complexity, software is becoming exponentially more complex. In infrastructure, we're seeing things like microservices, polyglot persistent, containers, Kubernetes, Docker, and others that decompose monoliths into microservices that are great for products but hard on humans. And the number of products of tools are also multiplying. There are countless of platforms and tools for empowering people to have better observability and control over the code. Great for users, but it's hard to choose which one is the best one. To successfully deliver and run a product or services under these escalating conditions, you need observability. Now that you know what observability is, you will be wondering why it's important and why you should care. With environments as complex as we see today in modern applications, just monitoring for problems is not enough to recognize and fix the number of issues that arise. Sometimes the new issues are unknown unknowns, which are problems you don't know, and even worse, problems that you don't know how to find. So without tools to observe the environment, it's almost impossible to solve the issues. This is why observability is important. It gives you the instrumentation you need to understand what's happening inside of your software and fix it. So a good observability tool it helps you find what and where the problem is. It just doesn't tell you, yeah. It also doesn't add overhead to your app because we don't want our app to slow down, quite the opposite. It also has enhanced security because we don't want our NPMs to make some data breach. Has flexible integrations and doesn't need to modify your code. It's important to differentiate between observing and also monitoring. There are two different things. So observing is exposing internal states to be viewed externally, but monitoring in the other side is collecting and displaying the information that has been exposed, and it usually involves some writing automation tools around that. So now let's imagine your productivity and confidence developing web apps without Chrome DevTools. Many do that exactly with Node.js. I think every web developer on the planet has used Chrome DevTools at some point, but not a lot of Node.js developers has used similar tools to observe and fix their Node.js applications. So if you want to solve the most complex Node.js problems such as memory leaks or performance issues, or even just to follow the best practice to keep your code healthy, it's necessary to have an observability tool. The next step will be choosing an observability tool that adapts the best for your needs. So choosing an observability tool. First, we're going to see which observability tools can be used in Node.js internals, and then we're going to check some external tools. There are different layers of observability tools. First, we can use for Node.js internal, service host, and finally the cloud network. In Node.js internals, the first one that we're going to see today is performance hooks. This is particularly helpful for checking on performance, as its name says. It's an object that can be used to collect performance metrics from the current Node.js instance. Performance monitoring is not something you should start considering once you start seeing performance issues. Instead, it should be part of your development process in order to detect problems before they arrive in production. Because of the asynchronous nature of Node.js, code profiling with regular tools can be challenging, especially because part of the time it could be outside of your code and it can be inside of the event loop itself. So that is important to use some internal Node.js tools like Performance Hook or external tools as we're going to see later. So let's do a little demo here. Let's measure for example, the performance of the 4 biggest search engine in the world: Google, Yahoo, Bing, and DuckDuckGo, using performance hooks. So we have here performance observer for performance hook. Then here we're just going to loop through these URLs, and using performance observer, we're going to check like the performance and the time execution of those 4 search engines. So if we do this, we can see that the fastest one is Google, followed by Bing, and then DuckDuckGo, and the slowest one, according to this script, is Yahoo. These times are in milliseconds. Let's look at another example. This one is just simply a simple Hello World app, but just using performance observer, and we're just going to measure the execution time of this very simple Hello World app. And here, I will just do. And this Hello World app takes 10 milliseconds to execute. So while performance hooks are very informative, there are some trade-offs because it requires instrumentation of your code manually, impacting readability. In case of performance observer, there are significant overhead costs to the observing. The next one is profiling. If we use the flag prof process, it will generate a log file. And this can be used to get like more human readable information like flame graphs. Flame graphs helps you see where are you spending time on your application. This can be very productive in getting insight of what's going on in your application, but the downfalls is that it has significant overhead, plus generating new files can be tricky. But you can extract like a lot of information here. The next one, it will be trace events. The trace events provides a mechanism to centralize tracing information generated by V8, Node Core, and user space code. Tracing can be enabled with the trace event flag command line that accepts a list of comma-separated categories named by using the trace event module. By default, Node async hooks, and VA categories are enabled. You can execute trace event enable flag to get the output of several events that happen inside Node.js. This can include accessing the file system, performance data, or async hooks, and others. You can configure which events you want to see by using the flag trace event categories, allowing users to create custom trace events and use them, for example, to see how long our operation takes. In Chrome, we can open this Chrome tracing, click the record button, and then it will allow you to visualize tracing like this. If we look at the bottom of the screen, you can see fs sync read, and this is a read operation of the file system. There are 546 bytes read. It's also possible to see when the tracing started, how long it took, the CPU duration, which is a very useful seeing what's going on with your code. This is another example of tracing, but using more processes and multiple threads. Here we are looking at the main thread and different useful information like direct time, processes that depend on other processes, arguments, and others. Tracing has less overhead profit, but management of the files becomes harder because this is looking at a lower level instrumentation of Node.js internals. The next one will be heap snapshots. A heap snapshot is a static snapshot of a memory usage detail in a moment in time, and it provides a glimpse into the heap usage of V8, the JavaScript runtimes that power Node.js. By looking at these snapshots, you can begin to understand where and how memory is being used. Heap snapshots are very useful for finding and fixing performance issues in Node.js applications, especially memory leaks that sometimes are super hard to find. A few years ago, developers had to use heap-dump module to obtain heap snapshots. But today, we have a built-in heap snapshot signal flag, which is heap snapshot signal, this one here. So you can set as many signals as you want. Oh. Can you one second. I think my screen just stopped sharing. Sorry about that. Like always technical difficulties, but it's fine now. So as I was saying that a few years ago, developers, they have to use the dump module to obtain heap snapshots. But right now we have this flag heap snapshot signal, so you can send as many signals as you want, and Node.js will dump the heap snapshots. Chrome DevTools allows you to compare snapshots, and you can identify objects in memory that will help you narrow down when there is a memory leak that might be occurring. So this is how it looks like. And this is how it looks in a very high level. The column of the far left, objects of the JavaScript heap. On the far right, you can see the objects count columns will represent how many objects are in memory. Also, the shallow size column, which is the amount of memory allocated to store the object itself. And the retained size column, which is the shallow size plus the shallow size of the objects that are accessible only from this object. In other words, the retained size represents the amount of memory that will be free, the garbage collector the object is collected. The next one that we're going to see, V8 Inspector. This is not an observability tool, but instead it's a development tool that helps you monitor what's happening in your application. A few years ago, Chrome DevTools was integrated directly into V8, expanding its capabilities to include Node.js applications. With this integration, it was possible to access step debuggers without having to install the Node.js Inspector, the Node Inspector module. There are a few ways to get started. One is using the inspect flag, which starts the inspector. Then you can pass a port, this one, that you can listen it, inspect, host, and port. But if no parameters are passed, it would use the default, which is in this case 127 port by default. One other way is more useful when doing local development using the inspect break flag. This flag has the same options for host and port than the inspect flag, but also puts a breakpoint before the user code starts. So you can do any type of setup you prefer without having to try catch, breakpoints, and you code at runtime. So let's look by a little demo here. Okay. The BA inspector here, I'm just creating a new error. It's called a new cool error here, using promise reject. If I want to use that break flag, I just do something like dash inspect break and the name of the file. And then we can see that the message printer is that debugger is listening to this WebSocket URL. WebSocket makes possible to open a two-way interactive communication session between the user browser and the server. We can also see a message that directs the user to the Node.js communication here, so we know what's happening there. Okay. Okay. If we go to the URL cram inspect, you will see something like this. And once you click on that, you will see a dedicated DevTools for Node.js link that will pop up a window for debugging your Node.js sessions. And as you can see in this image. DevTools is now connected to your Node.js just by using that link, providing you with access to all of the cram DevTools features we are all used to. This allows you to edit pages on the fly, access source maps for file code, live edit, concept evaluation with EXE's feature object, sampling JavaScript profile with Flame Graph, heap snapshot inspection, heap allocation timeline, asynchronous stacks for native promises. However, the V8 inspector should never be used because DevTools actions have the event. This is acceptable for development, but is unsuitable for production environment. For production environments, we will see later which is the best option. Some of the problems with things that Node.js already provides with Node.js internals like profiling, performance hooks, and others, is that it tells you that there is a problem, but it doesn't tell you where to find it. Also, sometimes they're not easy to implement. Give you enough information, or is not presented in an easy way, like graphs or center performance metrics that other external tools provide. Also has significant overhead, generally viable in production. And also it provides data overload, which means there is a ton of data and it requires expertise to separate signal and significant data from noise. There are also some pros because those are great tooling and they have extensive data and documentations and can give you a lot of insights. The ability to correctly monitor the process is limited on how much data processed. How data is exposed is the observability tool that we're going to see next. So external tools for Node.js Obs. The block npm package is a concise example of using timers for observability. It helps you check if the event loop is blocked, but it doesn't tell you where. It's useful for understanding the overall health of the event loop. It can have positives in some scenarios because of the timeout offset. In addition, it can also create numbing effect, alerting you event loop blocks, but not signifying or telling you what's actually causing the blockage. Many times, developers just ignore it as there's no clear action. New Relic is an observability platform built to help engineers create better software. From monoliths to serverless, it helps instrument everything, analyze, troubleshoot, and optimize your entire software stack, all from one place. It also provides different solutions, from cloud adoption to digital customer experience and different industries, just to name a few. This is how New Relic insights appear. You can see web transformation time, the application activity, error rate, host, and others. We also have Datadog. Datadog is very popular. It's a monitoring services for cloud scale applications, providing monitoring of servers, databases, tools, and services through a SaaS-based data analytics platform. With Datadog, you can check requests, latency distributions, error, percentage of time, and others, as we can just see here. The next one is Instana. It's an application performance monitoring for microservices. It lets you manage the performance of your application in real time and see every detail about the inner workings and inner dependency of your applications. It helps you trace events, distribute requests, map all services, profile every production process, as we can see in some of the metrics like calls, error, mean latency, top services, processing times, and others. There's also an external tool called Dynatrace. Dynatrace produces a software intelligence platform based on artificial intelligence to monitor and optimize applications performance and development, IT infrastructure, and user experience. They focus mainly on these 5 categories: advanced observability, continuous automation, AI assistant, cross-team collaboration, and user experience and business analytics. For Node.js observability, it can tell you the number of processes, CPU, and memory usage, the percentage of connectivity, availability, and others. I can't move my screen. What's happening? My second screen is acting weird today. I cannot move the slide. Oh no, what's happening? One second. It's been acting fine always, and today it just broke. My second screen. Well, I can just do this without the slides. Okay, but I can just keep going. So, Google Cloud for Node.js monitoring. The next one is Google Cloud. It was before called Stack Driver that provides monitor, troubleshooting, debugger, error reporting. But there is a problem with all of these solutions. The way that APM works is because they become agents. So they're just agents that, or intermediaries between your application and the Node.js runtime. The APM is injected into your code, and it encapsulates your application so they can extract the information. And that has a significant cost, also known as overhead. I have heard that sometimes the APM itself is the one that creates the performance problem. And as you can see, APM code and overhead, the time provide. Like CPU profiles, stack traces, and others, you can see the APM code and cost. Another problem is that sometimes you have to modify your own code in order to implement the APM or the observability tool, which create extra work and extra layer of difficulty that we don't want to deal with. Also, the accuracy is questionable. But they can be very useful tools that provide you with additional insights and extensive data and insight. But there's one tool that doesn't have this problem because it's not an APM. It's an enterprise runtime for Node.js, and it adds minimum overhead, and you don't have to modify your code at all. So this solution is called NSolid, which is a drop-in alternative for the Node.js runtime, enhanced to deliver low-impact performance, insights, and greater security for mission-critical Node.js applications. So it has faster time resolution, a stronger infrastructure, hardened security, zero code instrumentation. That means you don't have to change your code in order to implement it, and it also has minimum performance overhead. So, as the conclusions, I was going to show you some benchmarks about, but I cannot show you because my screen is not working. I don't know why. but I will share the screens. And as a conclusion, observability in Node.js is very important for security and performance. It allows you to filter faster. And if you are focusing on Node.js specifically, NSolid is the best observability tool out there. It's the fastest one, is the more secure. And other tools are great, but they come with a cost because they are not also. They have great overhead from wrapping the user's codes into their own libraries. NSolid avoids these penalties by observing the application at a lower level, allowing NSolid to make observations without directly affecting how the program runs. For other types of application, and depending on the needs, there are some other great observability tools that can add a lot of value. So I'm sorry for the technical issues. I will share the screens with all of, I will share the slides with all of you. And if there's any questions, I will be very happy to respond them.
And well done for recovering from some horrific technical problem there. Congratulations on doing a great job of carrying on, because that is hard work. So thank you. I'm afraid we're not going to have time to ask you questions here, but you are available on Twitter, and is that where you'll be sharing your slides as well? Oh, yeah. Amazing. Thank you ever so much. It was a really interesting talk, and I look forward to hearing your answers to people on Twitter.
Yes, for sure. Thank you so much.
Okay. Bye. So we've got one final word from one of our final sponsor today. So this is one from my employer and the sponsor of the host of NodeConf Remote, and that's NearForm.
Hi everyone, I am Matteo Collina, and today I'm going to answer a few questions about NodeConf Remote. First question, what are you looking forward for the first ever NodeConf Remote? We are the team behind NodeConf EU, and over the past few years, we really wanted to have all set of amazing speakers at the conference that could bring out the depth and of Node.js. We have beaten yourself for NodeConf Remote. The lineup is one of the best lineup we have ever had in so many years. We love it. We were able to do it because people don't have to fly across the globe. So we were able to access amazing, talented speakers from all over the place that could come and deliver their talks at NodeConf Remote. So the second question is, what do you think was the most significant progress in Node in the past year? Well, there are two main things. First one is AsyncLocalStorage. It's really good. It's a nice API. It's a new API that we have introduced that you can use in place where you're using continuation local storage, CLS hooked, those type of things. If you don't familiar with it, don't worry. It's probably low level, really low level. It's an API that you can use to track the context of your asynchronous call throughout the execution of a request without passing things, objects around. It's pretty nice. The other bit is, which is shipping in Node 15, is the fact that there will no more annoying and handle rejection warning. Your Node.js process is going to crash. Next question. Why is Node.js so important to developers now? Node.js keeps growing. The Node.js ecosystem is still growing, is still super widespread, is used in every single web application out there, either in the toolchain form or just on the backend, the API. It's actually everywhere. So it's a super good choice for developers to start. There's also a huge market for front-end and full-stack developers that focus on both the front-end like React or Angular or Vue or Svelte to Node.js backends. On top of that, there is all the tool chains for those things are built on Node, and new Meta cloud provider actually make it deploying Node.js even simpler. So there's no reason not to try to use Node.js for your next project. What advice do you have for people wanting to get involved in the open source community? Well, get started. There's no point. Don't wait. Don't think you're too good. Just do it. Sit down and do it. Simply put, just triage some bugs or do a little bit of docs or start fixing typos. Start. Get started. And that's it. What was your first ever Node.js project? Well, I think it was a tiny library written in CoffeeScript to generate unique IDs, like a URL shorteners. You know, those things were fancy a few years back. If you had to pick one skill for developers today to focus on, what it will be? Technical writing. You should really be good at writing things on explaining a technical concept in writing. A lot of developers are not good at that, and it's actually limiting their career progressions. So it's actually pretty important for developers to learn to write properly. In English, of course. What do you think is the biggest advantage to using Node.js today? Well, ubiquitous, maybe. It's fast, ubiquitous, and it's really quick to develop things on. Why Node.js has become so popular? Well, NPM. The NPM ecosystem exploded. We solved the Node.js and NPM community solved the problem of reusing software at large scale. That's just about it. And everybody is seeing the results. I would say thank you. This was fantastic, and see you at NodeConf EU.
Okay, and now for our final speaker today, we're going over to Brazil to join Erick Wendel. Erick has been named by Microsoft as a Most Valuable Professional, MVP. He is a specialist as community builder. Erick is a community co-organizer in Brazil and a software independent architect in serverless and container-based and hybrid cloud solutions. He's given more than 100 talks in 7 different countries, and he's created training courses in focusing on Node.js, JavaScript, and cloud computing. To top that all off, he also works as a voluntary leader of the Node BR, JavaScript São Paulo, and the NerdZone communities. Please welcome Erick, who will be talking about 10 secrets to help you improve Node.js security.
Hello, my friends. I'm Erick. I'm from Brazil. I'm super happy to be with you guys right here, like closing this whole event. I hope you enjoyed this talk. I've spent a lot of time building it for you. And this talk actually is a lot of tips to help you to improve your your current application. So I will show you a few of this example. Maybe you might know, but I know that there's a lot of people right there, and I hope to help you during this whole talk. By the way, who cares about app security? App security is something that scares a lot of people, but actually most of my customers don't care much about security. Actually, they would hire someone focused on security if something is happening or if actually there is some incident running over there. So this is super interesting. And most of their systems look like this, like, okay, we will see this application later. We can publish it in other platform. We can put on the cloud to improve security, but we know that is not that simple. And I'm gonna show you why. And yeah, do you think that JavaScript is do you think JavaScript is a really cracker-proof language? But yeah, I have a sad message for you. It's not. This actually is a very famous scandal that has happened on Node.js platform. As you can see, like millions of people were affected by this scandal. And actually, this was an error on the EventStream library. So the EventStream library had like a dependency, which was, let me see the name, flat map string, which an attacker just add this dependency as third part, and it was a backdoor. It was trying to steal actually Bitcoin wallets. So this was super malicious code, and actually something to care about, like money happening over there, and it's crazy. And actually we a few other huge problems on JavaScript ecosystem, which happened on the Lodash or jQuery, which was a vulnerability that you can inject code or just like do the neural service attacks on the Node.js object. So this is actually something that is already happened, and actually it has happened over all times. Actually, it was only discovered by last year, and it's something to care about. Like this package affected 4.35 million projects around the world. So yeah, we should take care about our packages. But this talk is not about only the packages. I will show you other approach as well. But yeah, maybe you use Lodash, and if you are on the older version, try to update it because there is actually a patch. But be careful on your packages. But yeah, most of you are thinking, okay, but this would happen if I'm running my application on a bare metal system or other like VM. But if I go to the cloud computing, there is no problem. So most actually of my customers things like this, like I have AWS, I have Google, I have Azure. They have certifications to take care about my applications. But we have actually a known attack, which is cache overflow. Basically, the attacker will throw requests on your application and steal your own money. Not actually steal your money, but spend your money on the infrastructure. This actually is something very common on serverless applications. So sometimes people just forget to add like public keys or whitelists for IPs, and actually it's public there. So attackers would run like a simple while true for or just some iteration. And actually, your application is high scalable, high available, and you pay per use. So this would spend your own money. And actually, it has happened to me, but it wasn't an attacker. It was actually a developer mistake, and we suffer really, really high. Okay, we know JavaScript is growing a lot. We have a lot of platforms, a lot of new packages shipping every day. But I think security is not following the same path. It's just a few companies that are trying to publish the vulnerabilities that will show you a lot today. And yeah, and actually, if you have something scandal, like if you work on financial companies or you just want to release new software and you lost like your customer's password or your customer's information, this is something really bad and you can lose the customer's trust. Before I dive in, all of this talk is already on my GitHub or already online, so you can get all the slides, all the reference that I will show you right here. But if you can, try to print some checkpoints from the slides, publish on Twitter, just mention like the conference, the NodeConf code, mention me as well, and it would be nice to people to see, look for talk as well. I won't code a lot today because my goal is to show it in practice. So I will show a few packages, a few practices. But if you want to code, I put all the reference at the end. You can see it later. Okay. Okay. Most of tips I got you. It's for you can use for any application you want. You can use on Node.js. You can use on Java, C#. A lot of them if you follow this. But I will get some. I brought just some categories for you, like this one. These are 10th, and the category is app. So just do not block your event loop. This is something that most of people look and say, okay, I won't do that, but man, this is super common in production. Some people just try to upload on CSV and try to interact the whole data from CSV in memory, like a while loop or a map, filter, and reduce. And actually, it stops the whole event loop for running. And then when you try to receive more and more requests, it's like a denial of service attack. But actually, it's not an attack. It's just a bad approach, a bad system design, which blocks your whole infrastructure. When running Node.js applications, try to run as simple as possible. This is something that you might heard before, but it's something to always remind and avoid this kind of applications. And to do that, use Node.js streams as much. I have this feature. It's already there since the first version of the Node.js. You can process data on demand. You can get data and you can split as a pipeline. Getting from the previous example, you can see like you can get the CSV instead, like getting the whole data and putting in memory. You can read this data as a buffer or split it in chunks, and you actually can get all of these chunks or actually your pieces of this file, and you can actually run it as a single element in the program. Like, yeah, for each element, I will parse to JSON, I will map it, and I will insert it on the database. This is something that you should search a little bit if you've never heard before, because using this one, you can improve Node.js performance, Node.js security, and a lot of other improvements. The best way to improve security in talking about APIs is using an API gateway. The API gateway will be the wall on your application, and all of the ingress or egress access, like all traffic, will be filtered by your application. So imagine you have a lot of customers accessing your application every day, but how do you know if it's an attack or it's just someone using a lot your application? So you can specify API keys, you can limit rate limits, And if you get something suspect, you can put alerts, and you can like specify which user is using more your APIs, and actually you can deliver features better to your customer because you know their behavior. However, there is a lot of features that you can use like this approach. Like imagine your infrastructure is running on an infrastructure in somewhere else, or on the cloud, or actually on your server on your house. When you have the gateway, all the attacks will go to this filter, which will be like the locker from the door. And if it's not like the API key or the IP or some key that you must have to access your infrastructure, all this traffic will be blocked and nothing will happen to your application. And even if something bad happened to your infrastructure, imagine your application is down, your load balancers are down too, and your customers are trying to access your APIs. So you can say, oh, sorry, mate, I don't know what's happening with my infrastructure, but I won't send you any sensitive information. This is something really nice to think about it. Great. Avoid secure identifiers and default ports. I don't know if you ever saw, but this is something really, really interesting. When you're creating our infrastructure, sometimes you open like MongoDB, Postgres, or whatever database or service you want. But we usually don't change the default port. I don't know if you ever seen this before, but sometimes attackers are always scanning your server, like your IP or your DNS, and they can see like these open ports. Like for development or staging environment, this is so common. Like, oh, people saying, oh, I just steal your database and you must send me Bitcoins because I want to. And this is something that I talk to my customers. So like, oh, Postgres is running on 5432, MySQL, MongoDB. They have all these default ports. You should, if you're not using actually an API gateway, change it all these default ports, because it will be a little bit harder for them to understand which servers are running in each port. And actually, this is something common as well, like incremental IDs on routes. And like, I've seen a lot of websites using the same pattern, like /users/1/users/2. And if you're like a smart programmer, try, okay, maybe this is an incremental ID. I will just run a for and download the whole database from this system. This is something really bad, but it's more common than we imagine. Instead, using incremental IDs, we can use UID. Like you can create a safe identifier, and it's even harder for the customer to understand, but you have a little bit working process on your application, but it's not so bad. So this is actually a very good practice to do it. And this is something that maybe if you ever search about security, and actually Node.js, most of them are about Node.js packages. Because Node.js packages, we are creating a lot of packages every day to like improve our productivity, to ship more applications faster. But we know that some people like to like prank people or just to steal Bitcoins over there. But yeah, packages are not so simple if you try to think like, how do I know which dependency from dependency has a problem? And if actually I found the dependency that is something like some high vulnerability, how do I know if I want to change it, or I just want to move on, or just block my whole application? I don't know. This is really hard. And I have some questions for you. How often you update your packages? I don't know. Most of my customers, they don't update. They just think, oh no, it's working. It's running in production. There's no problem. I won't change anything. That is already right. And this is something really hard to think. And actually, how do you know if dependency is safe to use? Like this case of EventStream, I think the impact was so awful because it's hard to know like the huge, like the end of the path for the dependency. So this is something to care about. But yeah, we have this friend, Liran Chao, from our amazing community. He built this tool. I just put the link as well there. It's NPKey. Use NPKey. You can use you can search for vulnerabilities on the whole tree, on the dependency tree, and you can identify which one is the problem. But actually, they use a sneaky database. So you can go to the database, you can find on the website and search, oh, is this package safe to use? Like, oh, Express, Mongo Express, Happy.js, and so on. This is super nice. And right now they just released VS Code extension, so you can install it. And when you're coding, you can receive hints like, oh, this is a vulnerable package, and you can click on fix it, and they will fix to the right version of this application. I like this extension so much because that is not so effort for us, like as programmer. We can just install and see the hints on the VS Code and know if something goes wrong before going to production and before being attacked. Nice. And this one, it's nice as well. Manage environment variables. Variables, we know that sometimes if you look to the GitHub, you can see a lot of credential loss right there. A lot of people publish these credentials by mistake, and it scares a lot of people. Honest, like, oh man, should I just publish it on a service? And how do I avoid some application to go outside or to attack my application to steal variables? This is something more sensitive to think about it. I've been using a lot System Manager from AWS to my applications. Like when I'm working in a team, the developers won't know where is the production variables or where is the database variables. You can just publish it there. The manager will just change those variables, and the production stage will be safe from everyone. And actually, it's super simple as well. Like you can define keys, and if you can click on these keys, if you have access to view it, you can see the value for this one. I know this is something looks like simpler, but it's not that common for people over there to do that. And if you use Kubernetes, you can use HashiCorp Vault, and you can put on a sidecar, and the container will exchange the variables through each other. So if other container in other place try to access the same variable, you can define, oh, this one have no access to get any data from my container. Yeah, but I know it's easier to publish it all on GitHub, but there is any way to publish it safely on GitHub. Yeah, we have Gitcrypt. You can publish your credentials right there, but you can publish it encrypted. So this is so much easier to do it, and you have no third-party services to manage it at all. Like your .env file, you publish it all on GitHub, and it's safe to use using like this. But you have actually a key to store with your team or your user to access it all. Perfect. You have to be careful when using Docker. I love Docker as well, but there's a lot of problems over there that we should take care. First of all, don't expose your Docker sock, because if your container have access to this Docker sock, they have root, like they have the main user for the whole machine or the whole container. They can install third-party applications, and they can do anything to your application. You can limit all capabilities. So you can say, oh, I don't want to, I need this container to be read-only. I want to use only the webcam, but I don't use the audio from the machine, and so on. So you can cap all databases. So nice. For volumes, you can mirror volumes on your application in your machine, but sometimes you don't know what is going on inside this image. So you can just drop all capabilities and say, oh, this is only read-only. I will there is no executable. They have no permission to add any file on my application. And don't use Docker Compose in production. I think this is more unusual, but I've seen a lot in production system. If you use Docker using Kubernetes or Docker Swarm or any orchestrator. If your Docker application are running on Docker Compose, if something goes wrong, your application is down and your whole infrastructure is down, you have to go to the container or to the machine and restart it all by hand. Okay, our fourth, handle network policies. I've talked a little bit about the vault, that you can like put all your environment variables right there, but you can cap all the external dependencies as well, the external calls as well. Using Kubernetes, you can deny all ingress capabilities, like any container would access each other. No one will access the internet. No one will try to send data outside if you don't want to. And you can use Intrinsic. Intrinsic is a good package for like limiting your Node.js packages. You can create like a policy, and actually there's a lot of good features right there. Like you can limit your outbound HTTP requests, the communication, and you can do all of these capabilities. This is super, super nice. They have tokenization as well. And so I will go through in these packages because I already put them on my reference, so you can look at it later. And that is something on Node.js 15, which is not stable yet, but I really like it, which is the policies. You can define policies on a JSON file, and you can specify something that the intrinsic are doing right there. It's really, really new, but I don't know what is the next step for that, but I'm really looking forward for this feature, and I really want to. Yeah. More top 3 is for tooling, to static code analysis. So you can install, if you use VS Code or any editor, you can install a lot of plugins to make sure that nothing will go wrong, like for outside. You can install ESLint plugin. You can install SonarQube. You can put a lot of plugins on SonarQube. And if you're thinking, oh, I have SonarQube, I have my dependencies, I have NPM or NPM packages, so we can install our plugin to check all the packages before going to production, and we can see it all on the CI process. This is really, really nice. This is something that anyone should have on their infrastructure. And actually, you can use Sneaky. So Sneaky is not paying me to say like that, but I really like their tools because it's helping a lot of developers for free. There's a lot of resources for this talk that I got from Sneaky, and you should look forward and you should look their application as well. If you're using GitHub or other repositories, they could open a lot of they could show you vulnerabilities, what you can do, which version you can do, and which is the state for this vulnerability. It's really, really nice. And your top 2 tooling is for monitoring, to monitor your application. This is something that you think, okay, I should monitor my application for performance, for reliability, or for observability, as Liz just talked on the previous talk, but you can observe for security as well. So we should know a problem before our customers. This is something that I've been using a lot in all of my customers' meetings. I said, man, if something goes wrong, I prefer calling my customer and said, oh, today I will be off, like my system will be down for an hour because we have something here. I have to release an update, and I can just create any story for that. But just it's really bad when they call, oh, my system is off, what is going on? So you know, and you actually don't know, and this is something crazy. I've been using a lot New Relic in all of these customers. I've been saying like customers because I used to work as a consultancy here, as a consultant actually. And these tools is helping them a lot for that. So you can create alerts, you can specify where is the problem in the packages. You can see like, oh, there is like a high level request here, I was what's going. So we will send emails for the manager, for the tech lead, and for all the team to look at this system before the customer will look. And this is something, again, it's something that everyone should have in their infrastructure, not actually the New Relic, but an application performance tool to analyze the whole infrastructure and to see before customers. And even though we know that some people, we work with trust people, like we trust each other, but sometimes, I don't know, we have to know what is going on AWS account or on your cloud provider. Using AWS CloudTrail, you could like see the whole logs of each one. Like imagine, by mistake, someone on your team just deleted your whole infrastructure. So using this one, you can receive a notification before it happens, or you can like say, oh, what you're trying to do, or you can actually monitor all your activity on your application. Yeah, this one I've been using a lot as well in big teams. When you have more than 10 people working together, it's good to know when something happened, because you can trace what happened on your Relic and your cloud, saying, oh, maybe this application just goes down because I have changed or I just removed a machine on AWS. And lock your computer after using it. Yeah, this is something I like to show security by creating tools, but it's just for pranking my friends, just to have some fun. But it's something to show how dangerous it is to like just avoid your machine unlocked. Like someone could install some malicious program and you can see it. I just built a VS Code extension, which is in Portuguese, so I will just translate for you. You know the comma, we have the semicolon. They have the Greek semicolon. When you replace the Greek semicolon by our normal semicolon, the VS Code or your code won't work anymore. But if you look at the semicolon, you can see, oh my God, it's actually the same code. Like here, I'll show you some demo. It's already on GitHub if you wanna look later. So here I have that .NET application, and I will install the extension and reload it. And then I'll go back and look, it's all green and it's saved. And then, oh my God, the whole code is gone. But if you look at the character, it's hard to define what's going on. Like it's a character. So this is something really terrible to do. And this one I just did with my girlfriend. My girlfriend were working and was working, and I just installed this extension to simulate Git merge. Like here, if you enter on her application, all the files you express like Git merge. And this is so funny. She was so scared, but do not forget your PC unlocked, because it could be very dangerous and very bad. Whew, a lot of content, isn't it? All of this content will go on to my website, so you can see all the talks I've been doing around the world, all of the content I did before as well. And this talk will be there for sure. And thank you so much for having me. I'm really happy to be here. I hope this talk was a little bit helpful for you. And if it was helpful for you, please mention me on Twitter, talk to me, because I really wanna know about it. If you wanna go to the websites or this whole reference I've been publishing here, this is the links. You can go to the slides, you can look it forward for all of them, and you actually can talk to me as well, okay? So thank you so much for your time again. I'm really happy to be here. I'm Erick Wendel, and thank you again.
Was excellent, and you are a lot crueler to people when they leave their screens unlocked than I used to be. I used to just change their backdrops to pictures of My Little Pony, but that was enough. If you worked on my team and you were ponied, you knew you'd been ponied. So, but it's a very good point, and it's one of the biggest security holes in development. It's just always remember to lock your screen. Got one question that's come through. I think we've got time for. So, Alexandri has asked, does npm check the integrity of the package that's installed in a project?
I have no idea for this question. I think npm audit will do something like that to check it all, but I'm not sure about the npm itself. But I've been using other tools like Sneaky or other like New Relic to check the integrity of the package, but I really don't know. Yeah, but we can ask for this npm guys. I'm sure they will have a certain answer for that.
Cool. Well, I'm going to draw it to a close there. Eric, thank you very much. That was an excellent end to an excellent day of talks. So, thank you all so much for being here today. I think I saw on Twitter at one point there were over 2,000 people online watching, which is an amazing number for an amazing conference. A big thank you to all our speakers. I've learned so much. I'm sure you have too. If you missed anything, please do visit the NearForm YouTube site, the NodeConf YouTube site, sorry, where you'll be able to catch up on the talks from today's speakers. Thank you again to NodeConf Remote sponsors, NearForm, Microsoft, Bloomberg, Red Hat, and IBM. Thank you very much to the NearForm events team and to Flux for running everything and making it go smoothly. And tomorrow, join us if you can. We have some great talks, amongst others, Joy Chung, Thomas Watson, Mael Nilsson, and Luca Maraski. I hope you can join us then. Thank you very much and have a good evening.